You have given me shoes! You have given me shoes! AK-47s for everyone! Hi. Hello. How are you? I'm fine, Chief. I'm good. Got a good night's sleep. I'm very good. I said I'd show up a little bit earlier because we got a massive plain SSTO thingamajigger to build. Thing. This is gonna be fun. Let's do it. I was talking with one of my uncles yesterday about Star Raker. He's an engineer, right? And I told him
Discovery, go at throttle up.
I told him what it was all about, and I told him about Star Raker and what it's supposed to do, and he kind of looked at me and went, What were they thinking? I'm like, I don't know. I couldn't tell you. Did I catch a 9er in there? What, you calling from a walkie-talkie? No, it's cordless. Booster 9 just did a spin prime. That's Pins Prime. Thank you. Quickly, before you get started, how's the situation with the tooth now? It's gone. Gone. Reduced to ashes. It's gone, and there's just kind of a stump where that used to be. It's very weird. I still feel it from time to time, Wolfie. Yeah, phantom tooth. Like, I go to eat something, I'm like, oh man, that hurt my tooth. There's no tooth there. Yeah, it's okay. Yeah. You have to wait a little while, of course, for it to graft before they can put an implant in. Yeah. So, it'll probably be like at the end of the year or something. I'm embarrassed. It's still embarrassing, man. I don't like it. Like, I didn't really pay it much mind until they actually pulled the tooth, and I was like, oh. Yeah. Alright. Well, anyway. It is what it is. MGS5, the Phantom Pain. Yeah, it is what it is, man. Not too happy about it. Got a couple missing. I know the pain, but being a Brit, you're a Brit, so you got a good excuse. Yeah, baby, yeah. All right. And mine tends to gnaw on the hints of shame from such things. Yeah, it is what it is, dudes. All right, let's get the tunage going. Yes. So we worked on basically all the like the mock-ups of where all the stringers are going to be. That's just, these panels are just basically there for me to get an idea of the wing shape and what we want for it. But we did redo the, I did end up spending last part 2 of the Star Raker build to basically just rebuild the entire fuselage. Prototype fuselage was not adequate. Yeah, this thing's a little crazy. I mean, it's gonna look pretty nuts when it's done. I was thinking, you know, maybe we could start working on the propulsion systems, and then start building out the rear thrust structure. But it probably is better to get an idea of like the engines. Yeah, the engines slightly angle up. We got that from the Dude, this thing is nuts. Like I said, my dad's brother is an engineer. He's actually he's an EE that works on trains, and I was telling him the finer points of starting up an old electromotive diesel locomotive, and he's like, "Yep. Where'd you learn how to do that?" I'm like, dude, I gotta tell you about this new game. He's like, yeah, I gotta prime it. I go, how many times do you prime the handle? He's like, 3. I'm like, yes, all right, I was doing it right. But I was telling him about Star Raker, and he's like, it's a little bit of a tall order. I'm like, yeah, I don't know what these guys were thinking when they designed this thing. But here, let me show you the PDF. I'll show you. We have a PDF that we've been pulling most of our research from. Here, I will show you. That's gonna be difficult to do. How was the sleep last night? I slept a long time, dude. I was not with it yesterday, dudes. I apologize for missing a day. I don't like doing that. Yeah, look at this thing. Satisfactory? Maybe later. We have to get work done on this, dudes. I mean, it really is a monster of an airplane. Like, alright, this thing is nuts. It really is C5 landing gear. I'm looking at the cross section of that landing gear. That's C5 landing gear. Look at the nose. See the nose gear right there? How it's one column down and 4 wheels. Here, look. It really is. It's freaking C5 landing gear. Nope. Get all that off get off the page, please. Use what works. It really, yeah, no, that's C5 landing gear, dude. It definitely is. I mean, it might be bigger tires if I had to guess. Also, C5s are really cool. We've been kind of dipping into C5 design a little bit because a lot of Star Raker's components are borrowed from it, or were supposed to be borrowed from it. But man, what a chonker of a freaking airplane. Yeah, T-Man, for sure. Is C5 the biggest gear? I'm sure it's up there. I'm sure it's up there for the biggest pop. It's probably that. I'll bet you this goes toe-to-toe with the Antonov 124, if I had to guess. Antonov 124, and, well, I would say the 225, the Dream, but I think the Dream's gear are just more AN 124 gears. Wasn't this originally supposed to carry the shuttle? There was a proposal for it, Nova, but it's too much. It's too much for the shuttle. The 747 was a much less expensive solution. Actually, the idea they had for moving the shuttle here is okay, so there's the shuttle carrier aircraft, right? Yes. So there's a shuttle carrier aircraft, right? 747-100 carries the space shuttle with a little bit of modifications to it, right? That's pretty good. This is what that was one of the proposals. Literally P-38 C5 thingamajigger. That, it's two C5 fuselages with the shuttle in the center. The idea with this is that you could the thing just rolls onto the shuttle and just attaches to it. You don't need a mate-demate device. But something tells me that a mate-demate device in the 747 is probably less expensive to maintain than whatever the heck this would have been. How heavy did they think the shuttle was going to be? Well, that's actually... Okay. All right, you want to get into this real quick? I got you. It's not... The shuttle's super freaking heavy. It is super heavy. It's 60 tons. That's gigantic. That weighs more than a tank. Well, yeah, about more than like an Abrams tank. That's pretty crazy considering, you know, it flies and a tank doesn't, right? The fact that we're even comparing mass is a little nuts, but the shuttle's beast. It's very, very big. Very, very heavy. So the idea with the C5 there, that 6-engine twin fuselage C5, the idea that what they wanted to do with that is not necessarily that like a 747 couldn't lift it up, for instance, because 747 can lift it up. It's range. Range is the problem. If the shuttle lands in California and needs to get back to Florida, it's 3,000 miles away. The C5, that twin C5 thingamajigger, could probably take it all in one shot. Take off in California, land in Florida. The 747 absolutely can't do that in one shot. It has the thrust to take off, but it can't do that in one shot. Turns out the shuttle is not very aerodynamic at subsonic speeds. Who knew? The 747 had to refuel 2 to 3 times crossing the country. Yeah, its range is only about 1,000 miles. Yeah, that's what they had to do. So it's not necessarily about weight, it's the aerodynamics. The shuttle flies like poo-poo, but that isn't anything we didn't know. That's a great picture. I like this one. Yeah, the 747 could move the shuttle around, but it's not very... It couldn't go very far. That's the thing. You saw that 747 land at my dad's Air Force Base once. Right on, dude. The SCAs are really cool. Pretty planes. I mean... The 747 looks good in pretty much any paint job, but I do like this straight blue stripe. Gray under, white top with the blue stripe. I think that looks... the NASA livery looks really, really nice. I mean, it really is a beautiful piece of equipment. Sorry, I'm just staring at it. I'm just staring at it again, aren't I? Whoops. But yeah, they wanted to try to do that to get it to go in one shot. Interesting kind of additional thing here. That right there is the reason why that existed. I really hate that I have to say that in past tense. I really hate that I have to say that in past tense, but that's the reason why that's the reason why the Soviet Union built this thing. They built this plane to be able to move a Buran from Moscow all the way to Baikonur. That's a long way. That's a very long way. That's why the plane exists. Because across the U.S., you have plenty of places to refuel. Russia gets very rural very quick. What about the 747 for the Saudi Arabia paint job? What about it? I've never seen it. Now somebody's going to come up with an ugly livery for the 747, huh? Alright. Alright. It is faster than a mate-D mate device, though. But once we gave up on the original launch cadence, the mate-D mate device was good enough. Aqualix, I actually prefer the Air Force's... Here, I'll show you. I actually prefer the Air Force's solution to this problem. So, the Air Force had this built. This thing. That is a portable MDD. You could basically set this up anywhere. Yeah, it's a mate-D mate device that you can just move around. This was originally built to get the shuttles on top of the 747s at Palmdale, and then they would have moved this thing in between Vandenberg and Palmdale anytime a new shuttle came off the line. Yeah, that's, I like that solution better. That is a much simpler solution. And then the absolute simplest solution was literally just use two cranes with the damn bracket. I call that one the SpaceX solution. That, they kind of proved at the end of the shuttle program that that absolutely works. I prefer it getting towed by a Toyota. I will time you out. Wondering how much weight it is for that much paint. Oh, I don't know. Probably a lot. The paint is not that heavy comparatively, but yeah. Turns out that a Liebherr 11,000 and I mean that says Loma on it, but that's the name of the company. That looks like another Liebherr telescoping crane. Yeah, as long as you have the bracket to move the spreader bracket to move the shuttle around, all you need is two cranes. Anyone think that they're actually going to rebuild the 225? There is another fuselage around, dude. There's another fuselage. It just kills me to look at it, dude. That sucks, man. All that engineering down the drain. It hurts, man. That freaking hurts. But that's what you get when you stockpile fuel next to the damn thing. I'm not sure, Nova. Maybe. It's hard to look at, man. I mean, that's a write-off, guys. You're not... You may be saving some components from that thing, but that's about it. You're not saving much. But I did kind of look at it a little bit when it happened a couple years ago, or well, last year. I did look at it and I was curious because, like, if you look at all those pictures of the thing being junked, like, okay, so this is clearly a fuel fire. It's clearly fuel, right? Very clearly fuel. See all the soot, like Falcon 9. It's very clearly jet fuel or diesel or something. But you also notice that they were storing equipment underneath the wings inside of its hangar, inside of its tent hangar, right? Somebody was storing something there. I don't know whose equipment that is, but that looks like maybe a Tunguska or something. Somebody was storing something. And collateral damage, man. I don't think anybody willfully destroyed that thing. I think people were trying to get at the equipment that people were storing underneath it. Maybe as some kind of weird deterrence thing. Oh, don't shoot the plane, right? You don't want to damage the plane, like holding the plane hostage or something. But it's very clear that that's what was going on. They were storing freaking... I mean, I don't even know what that is. Maybe a munition? But it's very clear that something important was next to this thing, and whatever was next to it... I mean, let's be real. If they wanted to blow the plane up, that there would be no discernible piece of this thing left. This is a fire. This was caused by a fire next to something, or whatever's next to it. See, look, there's tank parts everywhere. See the idler wheels? There's pieces of tank everywhere. So something blew up next to this thing, and it caused a fire, and the fire is what burned it. Turns out aluminum is great solid rocket fuel. Go figure. Go figure. Aluminum burns really, really well. It's really good. It's really good solid rocket fuel. What the heck? I mean, I don't know what to tell you. People forget that the paint on the aircraft isn't just a pretty thing. The paint does a job, and you might as well make it pretty.
Discovery, go and throttle up.
I agree, and I understand what you're saying. Aqualex, I'm going to be that guy. I apologize in advance. That's a vibe. Hey, Alleviate. What's up, Teekers? How you doing? It would still be in great shape if the airport of a peaceful country wasn't attacked. That's like saying, how dare I store gas from my mower in my garage because someone might break in and set it on fire. King, you misunderstand. I know. I know. Yeah, no, it probably should still be in one piece, but Buran should still be in one piece too. You know, like, I get what you're saying. Yeah, absolutely. That's not what I'm talking about at all. I'm talking about whatever happened. I mean, I think it's kind of given. It's kind of a given that I don't want the biggest plane in the world to be in pieces in a hangar somewhere on fire. Like, I don't... it's kind of weird that you would think that I would want otherwise. That's a little strange. But, alright. You feeling alright, man? Even if the shuttle wasn't retired, do you think it would still today be stuck in a launch cadence that is way less than it's capable of? Yeah, probably. Probably fly on the same frequency as Dragon. Never understood the woodland camo on airplanes. It's for when it's on the ground, Surge. It's hard to see. I mean, I'm not gonna lie, I kind of like it. But then again, I guess where you're coming from is like, well, when it's on the ground, it's hard to see, but when it's flying and it's an airplane, its job is to fly. I guess that kind of makes sense. Yeah, I know. I know, Lex. It was kind of joking. Well, actually, it was a joke. Yeah. I guess subtlety is lost with this crowd today. That's all right. How's your day going? Chat's making my job a little bit harder today, Tactical, but that's fine. Other than that, it's going pretty good. That's what you get for starting early? Yeah, I guess so. I need backup. I don't know if anybody was keeping track from the other day. I think I got asked through the course of the rest of that stream, which probably was, I don't know. I think after we had that conversation, it was like maybe 8 hours of stream after that. I got asked. I saw it 5 more times. So, yeah, I mean, coupled with the 2 or 3 times that it happened before that, I'm basically getting asked once an hour why I'm not playing KSP right now. KSP 2, yeah. Once an hour. Make an online counter or something? Nah, I'll just get a little clicker. You know? Why aren't you playing BattleBit? Oh, don't start with me, man. Please. So questions for EJ in chat. Why can't they build new versions of old planes, like a new C-47 or DC-3? I mean, they could.
Discovery, go and throttle up.
Alright, everybody's a little uptight today, guys. It's Friday. Just calm down. Let's go. Why no F1 manager? I mean, dude, they don't build that because that's kind of... I'm pretty sure those planes are grandfathered in terms of safety designs. It's kind of the same reason why you don't see old cars. Like, you're not going to see a new 1959 Ford, right? F-100, right? Why not? Well, seatbelts were optional on that car, and that's not a thing. And airbags, you have to have airbags on a modern vehicle. I would imagine that plane safety regulations are probably somewhere similar to that. Like you won't see a recreation of a classic car by an automaker because they can't. You can't make new VINs. You can't make new VINs for old cars. Because they don't meet safety regulations. That's how they regulate the automobile industry, the ability to create VINs, to make serial numbers for cars. So I would assume, like, that's cars, and cars have gotten pretty damn safe over the last 30 years, right, comparatively to previous. Excuse me. And... and I would assume that airplanes are somewhat similar. I mean, maybe you could retrofit the plane with all new, like, safety equipment and stuff, but yeah, I don't know. I'd like to see a side-by-side crash test of a Model 3 versus your Cornet or your truck. There's an there's an old video that's really difficult. There's a video that's hard for me to watch. I really don't like watching it, but it's kind of what you're asking for. It's really, really tough to watch. The Consumer Reports crashed a 59 Bel Air into a 2009 Malibu. I understand that cars today are safer. I get it. I get it. I understand. With that being said, this is really freaking hard to watch. Ah! Oh, it was IAHS, excuse me. It's really tough to watch, man. I can't. Oh, that car is mint. What are you doing? Damn it! No, seriously though, there's some real old cars aren't made without crumple zones. There's no way to disperse the kinetic energy. You end up becoming the crumple zone. Like, watch when they show the interior cameras. It's not good. Okay. That dashboard is money, right? It's really cool looking. It's supposed to look like a fighter jet, right? But also, I mean, here's the thing. They learned over time. They learned that a collapsible steering column, so a steering column, the thing that you use to drive the car, that the linkage to the steering, right, has to have you should make it collapsible. It should have its own crumple zone, and here I'll show you why. Watch the steering wheel and watch the guy's head. Oh, that, yep. Yeah, I get it. With that being said, the truck has a collapsible column in it because I don't need to eat steering wheel if I get into a crash. Yeah, that's a broken nose at the very best. Yeah. But there's another kind of addendum to this. I don't drive my old car fast. No way. We don't go fast in that thing, because that can happen. Yummy steering wheel. Oh, yeah. It still hurts to watch, though, man. That's such a nice car. I'd be nervous driving the 59 after this. The 59 has belts, it has seat belts, and it has a collapsible column. I mean, you still got to be careful, but yeah, it's all right. Also, the Coronet is super slow. Thank you. Just try not losing a wheel. Yeah, that's, we can make it fast. Chad's on a rage today. I don't know what it is, Pacey. Everybody wants to just be mad about stuff today. It's really annoying, actually. Not gonna lie to you guys. Really don't like that. I read somewhere that the origin of the Finn cars was that a designer at GM really liked the P-38. Oh yeah, it's airplane inspired. Dude, a lot of cars from the 60s were. My personal favorite is a 64 Galaxy. The front doesn't look, I mean, it looks space age enough, right? It's the back of the 64 Galaxy that looks awesome. Dude, The taillights look like jet engines, which is just... Oh, that's so good, man. That's cool. The taillights look like... They look like ion thrusters, man. And then knockoffs and stuff. See the knockoff rims? That's kick butt, man. Such a cool car. Brimo and I have been rewatching Mad Men, and just the cars, dude. The cars in that show are so nice. Not safe to drive, we've established that already, but also they're really beautiful cars. Dude, yeah, look at the back. Look at the back of this thing. Oh, that's so freaking cool, man. That's such a cool car. The Americans is another great show from that time period. Yeah. Yeah. Actually, you know what I've been digging? Low and Slow, full size lately. It's mostly because of watching Mad Men. Like, look at this thing. Look at this freaking limousine. Oh, that's killer. It's freaking sweet, dude. There's something about these cars, man. I don't know what it is. It's horrible. It's totally fuel inefficient. I get it. It's got like a 8-liter engine in it, but it's very classy. Very classy. Very classy. You know, you drive around a car like that, people are like, whoa. Even now, like, damn, dude. We need more boxy cars. I can't stand the curves. I agree. And, dude, personal thing, like, this is one of the few things, like, I agree, RE cars with James May. We need cars that are comfortable to drive around in. I hate how everything is a Nürburgring, Euro touring, DTM, freaking piece of crap kind of rolled into what, like, everything has to be a 3 Series. I really don't like that. I really don't like it. They killed the comfortable car, man. You got to see Kennedy's limo in Detroit. It was a beautiful car. Tigris, that's a 64 Continental. Lincoln. Very, very nice car. The engine production in the 60s must have been insane. They had foundries cranking out engines 24/7. I mean, they still kind of do, T-Man. It's just not at that scale, but... Actually, one of my cousins has a 64 Lincoln, and it's suicide doors. It looks like the one from the Matrix, from the first Matrix. Listen up, Copper Top. It's our way or the highway. It's that car. It's freaking, dude. It's cool, and it's on airbag, so the car rides. It's nuts, man. With efficient as cars now and with how good tires are, why can't they give up a little aero efficiency in order to have cars have that style for a change? We kind of do that over here a little bit, Tessa. I mean, the Challengers... Dude, here's the thing. Boxy can be aerodynamic. Look at the Space Shuttle. Kind of a weird example, but the Space Shuttle doesn't look like it goes fast. It goes faster than any other plane. The SR-71 looks like it goes fast. The Space Shuttle goes 5 times as fast. Just saying. I hate crossovers, Aqualux. I hate them. Like, I can't stand them. That's my kryptonite, man. It's my kryptonite, dude. The old Falcons and T-Birds were the best Fords. I like Falcons. Falcons are really cool. Helvish, we actually got work to do on the Coronet. I have to fix the brakes. The main brake line going to the back popped the other day when I was bleeding it. I'm thinking, I think I told you this yesterday. I'm just going to, I'm going to splurge a little bit. All 4 new wheel cylinders, all 4 new drum brakes. Let's do it right. Let's do it right, and let's start fixing the stupid thing. It's really bothering me seeing it just sit there, especially since Freb runs now. We still have some work to do on Freb. I want to put gauges in it. And I have to fix the tack. The tack doesn't work. You were referring to the Cadillac suspension. Oh, okay. That's why Cadillac created the magnetic ride suspension. Get both. Yeah. Not swapping the discs in the front. Tessa, a little while back, I redid the entire front brakes, except for the wheel cylinders. So it's got new brake hoses, new stainless lines, and a new master. I just didn't really touch the rears because the rear was fine at the time. The rear brake line has since rusted away, so that's good. I don't know if swapping the discs is in the cards, but I agree. The only reason I have a Bolt EUV is that it was the cheapest EV out there by the lot. Yeah, I get you, man. Can Fred get a fake order pizza button? No. I think Edison has the right idea, Thomas, to be honest with you. I think the Edison trucks are a really smart idea. Diesel electric trucks are something we should have done in the 50s. It's kind of stupid that we never did that. We did it with trains, and we were like, yeah, this is great. And it is great. Hello? I mean, trucks with dynamic braking, just like trains, that should have been a no-brainer. And trucks with regenerative braking. Hello? Why haven't how many trucks could we have saved crashing off the road if we had those things? Like, all right. I can't stand F-150s or modern trucks. They are not utility vehicles. They are modern-day Cadillacs pretending to be trucks. Serge, yeah, we are in absolute agreement. I don't really understand why somebody would buy an F-150 4x4, lift it, and put gigantic rims on it. That literally makes it do everything that it was designed to do worse. It's a weird concept to me. I mean, with that being said, hey, it's your car. You do what you want to do. That and I would have preferred the EV versus the EUV, but yeah, they're fresh out of the EV version when I had to buy it. Fair? Why not a generation system that uses suspension to generate power? With magnetic suspension, Hellfish? So we're talking electromagnetic suspension? I'm not sure the energy that you're going to scavenge there is going to be a lot. I mean, imagine if highways had catenaries. I mean, we have electric buses in Boston that have overheads, interestingly enough. I mean, I know that's not what you're talking about. Speaking of old relics, here's one. Alright, let's get in gear. Let's get going. Speaking of trucks. Growlers have arrived. Oh, nice. And the Connie is right there, too. It's a beautiful plane team, man. I love how Chance, the guy in charge, has thrown around the idea of using ATS as a way for people to spec out their trucks. What, you don't like a truck with a 15-inch lift, 32-inch rims, and thin tires? Yeah, Atlanta, No. Yeah, I know it's a joke, but no, I don't. Trucks are a utility vehicle. They're a utility vehicle. I will not be taking any questions about this. They should be used for work, not for play. that... I'm becoming an old man, aren't I? Crap. Self-introspection is important, chat. I play at work. Dude, so do I. But all my trucks are single cab. Actually, I will say, I'm just going to say it. That F-250, the F-250, the Tough Enough with its long bed is one of the most handy things to have around the house ever. You can move sheets of drywall in that thing. I did to build this office. Yep. Yeah, trucks are the #1 sold vehicles that dominate the roads. It's crossover SUVs more than trucks nowadays, Thrasha. Crossover SUVs are just lifted station wagons, to be honest with you. They really are. Anybody that says anything differently is crazy. They're just lifted station wagons. Welcome to the Old Man Club. Hey, Tack. Is this bad? I heard about that catastrophe you had. Crossovers all over the place. Ando, it's insufferable, dude. At least you guys still do cars over there. But it's starting to get to you. Don't let it. Don't let it. Take it for... Dude, there's crossover SUVs everywhere. And you know what? Nobody knows how to drive them. Nobody knows how to drive them. Imagine diesel-electric semis with buffer batteries and overhead power on the highways. Yeah. Nah, it just means you're still making laps around the sun. Yeah, there you go. And Ando, manual transmission cars are like a luxury over here. I'm serious. Dude, kids, they don't know how to drive stick. Heck, a lot of young adults, a lot of kids my age, no idea how to drive it. They have no idea what they're doing. I'm just like, what? Dude, they don't know how to, yeah, they don't know how to drive stick. I mean, it's good for me because that means no one's going to steal the car because they don't know how to drive it, which is pretty good. I mean, don't get me wrong, guys. I like EVs. I don't mind them. I think EVs are cool, but nothing compares to rolling through the gears. That's fun. It's really fun. Really, really fun. That is a fun time. Even in the F-250, just it's awesome. It's such a good time, dude. I've driven automatics and I still prefer manuals. Half of my fleet is manuals, dude. The Coronet has an automatic in it, but we should fix that. We should put an 833 in there. That'd be kind of fun to do. It's fun trying to dodge an F-150 while working on a road with no shoulder and very narrow. Yeah, dodge an F-150. I see what you did there. In the UK, you have 2 grades of license, manual and automatic. Passing manual entitles you to drive anything. Side note, 90% plus take the manual, and under 50% of new cars are manual. Yeah, EVs can have the manual transmission, Aqualux, but let's be real. The instant torque will probably destroy a transmission very quickly. Unless you have some kind of progressive torque controller, or you know your ECU is basically telling the EV to work like an internal combustion engine. Having a manual on the electric motor is not a good idea. It'll literally just destroy a transmission. Instant torque, man. What do you want? Like, actually, you know what would be a good idea? Two-speed rear ends with a with an electric motor. That now we're talking. 2-speed rear ends are really, really strong. Now that I'm thinking about it. There's a rule in Poland: if you pass your driver's license exam in an automatic car, you are forbidden to drive stick. Interesting. Your 350 Tigris is a 5-speed manual. My guy. Being able to pick your gear properly saves on fuel, not sticking a brainless automatic in a vehicle. Tigris, when I moved outside of Boston, I moved about 30 miles outside of the city. It was a 30-mile drive between the apartment and here. In my 97 F-250 with 351 in it and a 5-speed with 410 gears, I got 25 miles to the gallon. That truck weighs 6,000 pounds, not including the load in the back. 25 miles to the gallon. That's pretty good, and it's because of the manual. You're right. You're absolutely right. Interesting that you guys do that. It's gonna be a sad world when everything EV is born. EV. Yeah, Bub. I see what you're saying, dude, but I mean, you can't deny that the Plaid is a freaking cool car. Plaids are awesome, man. That's the kind of EV I want to drive, dude. If I was gonna drive one, I mean, don't have $100 grand, but that's the kind of EV I would want. Interesting, Sparrow. Yeah, that's what I mean. If you wanted to put an electric motor and put a 5-speed transmission behind an electric motor, you would need some type of software to make sure that that electric motor, some type of governor, to make sure the electric motor doesn't grenade your transmission. Like what you're saying. Automatic is boring to drive. Yeah. And there's me and my 1.6 diesel Golf getting 72 miles to the gallon. Diesels, man. Isn't automatic way more efficient than manual? Not necessarily, Carlos. I'll be honest with you. If you have like a old, like 1970s Volkswagen with a 5-speed in it, you're gonna get like 40, 50 miles to the gallon. The reason why is the engine's gutless, and you have to be very careful about revving that thing. You know. Dude, even like a Camry or Toyota Corolla from the 90s with a 5-speed in it, those things can get 40, 50 miles to the gallon, no problem. Honestly, it's how you drive the car. How you drive the car makes the difference. It's your driving ability. Like, that's really what messes with your fuel economy the most. If you drive like trash, you bury the accelerator, you're good. Yeah, you're not going to get good fuel economy. It doesn't matter what car you have. I do not understand this car talk. I can't drive because of epilepsy. Oh, I'm sorry, Serge. That sucks, dude. Can you imagine an EV motor with a superconductive core? A superconductor core. That would, yeah. That LK99 needs to be real. I want to believe, Shy, but peer review is peer review, man. We gotta wait. The Toyota design is the computer regulate output to simulate a transmission. It doesn't even have a transmission. The computer fakes it. It's like driving a Why would... See, Sparrow, I don't understand that. That's just hitting copium right there. That's just hitting the copium, all right? Like, having not even having a transmission, but have an electric motor mimic a transmission, mimic what a transmission does, is taking all the good things about an electric motor and making them worse. That's the same type of, like, kind of weirdness that I see when somebody buys a utility truck, lifts it, and puts huge rims on it with rubber bands for tires around the rims. Like, you're literally taking all the things that make the thing good and making them worse. I don't understand that. Like, why would you have an EV? Why would you want to make it like an internal combustion engine? What that? Yeah, I can understand that, Aqualix. Yeah, for sure. I think people go overboard with it, dude. I saw a stanced car, a stanced G35 on the highway the other day, and The guy had cutouts in his car, like exhaust cutouts. They're basically a little butterfly valve on the exhaust to bypass the muffler and make the thing loud. And the guy had them open. It was pretty obvious he had them open. But there was something on the exhaust, like with the butterfly valve, that whenever the guy opened the cutouts, it literally sounded like this. It sounded like a typewriter, like something was rattling around. So the guy opened the cutouts, and his car sounded like if you took like a soda can and filled it up with change and started shaking it around. Yeah, I was like, that doesn't... Dude. Just tighten the bolts. How do you not notice this? Your car doesn't sound good. It sounds broken. I've seen trucks that make smoke. Oh, rolling coal. Serge, I understand why they do it. But there's guys that roll coal to make more power for the motor. Basically, the idea is that you run fuel rich with a diesel. You run fuel rich, and you basically flood the engine with fuel, so all the fuel combines with all the oxidizer that's going into the engine. I get it. You do it to make power. With that being said, there's two types of people that roll coal. There's the people that want to make more power with their engine, and then there's people that want to just spray other people down with carbon soot. Yeah, the second people. Nice. It's okay. He felt bigger when he pulled the lever. Yeah, I don't know. Gil Banks is pretty adamant that rolling coal is just wasted fuel. That guy does know a lot about diesels. That is true. I mean, yeah. Hellfish, I suppose the argument is that I would run if I was running a diesel and I wanted to do that, I would run slightly on the fuel-rich side, just for temperature. Especially with a turbo diesel. I would run slightly on the rich side. And I'm not sure if Banks... I'm not sure that's what Banks does. I think Banks tries to shoot right down the center for straight stoic. I'm pretty sure. I saw that whole fiasco he had with Hoonigan that one time. Yeah. Oops. Yeah, Banks' YouTube channel's pretty good. Are you curbled yet? Nah. Banks goes for stoic. He wants white smoke, not black smoke. I'm waiting for updates, Thrasha. Yep, that's what I'm doing, dude. Yeah, but running just slightly rich isn't going to roll coal very hard. It might barely be visible. Yeah. I mean, as case, like, once again, that's just me knowing nothing about diesel tuning. I mean, that I'm getting that from rocket engines. I would run slightly on the rich side, just because, like, to the point where, yeah, it would just be a little bit of smoke, like a semi truck, right? Because I do it for temperature purposes. Because if you have like a turbocharger, the turbocharger is going to need to stay cool. Same thing with a turbine on a gas generator in a rocket engine. Same idea, right? Like, you'd want to run a little bit on the rich side for temperature control, but rocket engines aren't diesel engines. Hey RT, what's going on? I know, Hellfish. Yep. I'm keeping track. Yeah, being sprayed with soot. Yeah, Serge, those people are jerks. I don't like those people. Those type of people aren't car people. They're idiots. They're people that want attention. What's this beast called in real life? It's called the Star Raker, Odom? Yeah. Star Raker, it was a concept. It never became a thing. But we did find... Here, guys, let's switch gears. Not rolling coal. To Star Raker. Alright, so Star Raker was an idea that was proposed by Rockwell. Rockwell is the company that made the space shuttle. Ironically, they were proposing this at the same time as the space shuttle was being built, which is a little weird. But, hey, whatever. So, the reason why Star Raker was being proposed at the same time by the same company that made the space shuttle is because Star Raker was a response to a project called SPS. Basically, in the 1970s, oil was at a premium because OPEC shut the taps off to the United States, and that made fuel prices skyrocket through the roof. All these cars that we've been talking about, these old cars, literally became uneconomical to run overnight. Yeah, quite literally overnight. So we needed to find other ways to generate power. The U.S. went looking for other ways to generate power. What they came up with is building solar panels in geostationary orbit and beaming the solar power down to the surface using microwaves. And in order to do that, in order to construct these solar panels on any timely basis, you would need one of these things. You would need some type of vehicle that can basically go up to space every day. Not every 4 days like what Falcon 9 is doing, literally every day. And that's a really tall order. But Rockwell was like, hey, we can do this. So they came up with Star Raker. Star Raker is a horizontal takeoff, horizontal landing SSTO. Single stage to orbit, meaning you take off and you fly right up into space. It is truly something out of science fiction. And I will say it's still something out of science fiction. Somebody might be able to do something like this in the future, but you got to remember, this is 40 years ago, right? Actually, 45 years ago when this design kind of came around. Star Raker's absolutely massive. It is, I mean, there it is. There's a render of it done by an artist next to an AA 747-100. And 747s are not small. This thing is on another level of big. And that's the reason why we're talking about 225, the AN 225 and stuff. Star Raker would have had two principal pieces of propulsion in it. The first one is air-breathing engines. The air-breathing engines, there's a render of them down here. Here we go. So, you guys remember the turbo encabulator video? It's basically that. Multi-cycle air-breathing engine, turbofan air turbine, turbo exchanger ramjet. I'll be honest, if I didn't see this PDF with some analysis being done on this, this sounds like something somebody would name their engines in Kerbal. This sounds like a name that Jeb came up with. Which it's kind of is a reflection of this entire project. Star Raker is insane. It is absolutely bananas. This seems like something that somebody built in Kerbal Space Program, but so I was like, oh, this project's perfect for Kerbal. So, Star Raker would have had 10 of these things. They're liquid. I could get into multi-cycle air-breathing engine, turbofan, air turbine exchanger, ramjet. Long story short, it is a intercooled SR-71 engine running off liquid hydrogen. Think what the SR-71 engines do. They're turbo ramjets. But this thing has an intercooler. They have pre-coolers on it that are using liquid hydrogen to cool the intake air and then spray the hydrogen into the engine and do jet engine things. It's a little more complicated than that, but basically they're liquid hydrogen SR-71 motors. So like they have a jet engine element and they have a ramjet engine element. It's basically an air-breathing rocket engine. Interestingly enough, it's kind of like the Rapier engines in KSP, but it's more like the Whiplashes in KSP. But either way. So it would have had 10 of these, and those would have worked in ramjet mode, taking off, and then the thing was supposed to fly up to... It was supposed to basically fly out of Florida, turn south, get to the equator, and then pretty much do a nosedive at the ground to get the airspeed into the engines fast enough for the ramjets to take over. And then it was going to pitch up, and the ramjets would have taken this thing all the way up to 2195 meters a second staging velocity, which is about a quarter of the way to orbit, pretty much around a similar velocity that you'd get from a first stage. And then from there, the 3 center engines ignite. So what are the 3 center engines? Shuttle motors. Because, you know, how much complication do you want? All of it. There's basically a space shuttle engine section glued to the back of this thing with 2 shuttle ohms thrusters right there. So the back of this in the center is basically the space shuttle with 10 SR-71 engines flanked on either side. The vehicle has basically what amounts to the shuttle's external tank shoehorned into the back of the vehicle. There's the space shuttle ET is in the back. Here, let me show you the cross sections. They're actually down here. Now, see right there? It's the hydrogen tank from the ET. Don't worry, the liquid oxygen is in the wings because this thing was going to have bilobed wet wings with liquid hydrogen and liquid oxygen. Like I said, how much complication do you want? All of it. This thing was going to carry cryogenic propellants in its wings. A cryogenic wet wing, which is... okay. How far did the project get? Didn't get far. I'll get to that, some guy. It didn't get much further than this, but I'll say why in a second. All of the complexity, except all the risk, it is the only way. I mean, Rocket, I'm kind of with you on that one. Like, you know, it's kind of a joke, but also at the same time, I mean, if you're going to go for broke, freaking go for broke, dude, right? Like, if anybody could do it, Rockwell probably could. I mean, they built the space shuttle. Like, if any other company tried to do this, I'd be like... But Rockwell in the late 70s was fabricating space shuttles. They had a lot of know-how into building reusable vehicles. Actually, more than pretty much anybody else, right? Like, at this point in time. But we were doing a little bit more reading about this, Rocket. The interesting thing here, so check this out. If you look at this, right, they would have been spraying Sophie in here between the outer wing edge and this inner structure. The inner structure are the wing tank structure. Those are bilobe tanks. Think X-37. Or not X-37, X-33. So the fuel tanks inside of the wings, they wouldn't have been like true wet wings, like the wing is just filled with fuel. But it would have been more along the lines of doing this. Like, the internal structures would have been... it's more fuel tanks, bilobe fuel tanks, kind of like this, inside of the wing. Now, that's not... that kind of makes it not as bad, I suppose, but this is still, like, absurdly complicated. So with bilobe designed tanks, we know it would have been canceled with the first prototype finished. Don't get real on me like that. Why would you do that? Don't get real on me like that. Come on. Shuttle tiles for re-entry. They were toying with 2 different types of thermal protection systems, Bond. One of them would use the shuttle tiles, the silicate tiles, RSI, using LRSI and HRSI tiles. So LRSI tiles are the white tiles that you see on the space shuttle, and HRSI, heavy resistance silicate something or other. I forget what it's called. I forget the acronym. I don't even think those words that I just said were right. I know they're silicon based. They're shuttle tiles. They would have basically done the exact same thing, gluing the tiles to the structural fuselage. Now, they would have had a thermal insulative layer in between the tanks and the wet wings, but also dude, the thermodynamics behind this would have been a nightmare to figure out in the 70s. It would be a nightmare to figure out today. That right there, that's nuts complicated. It doesn't look like much, but they were going to make this thing out of aluminum, right? I don't know how they would have gotten around the foam not cracking internally. This is, once again, this is like taking the external tank, which already cracks the foam, and putting it inside of a gigantic shuttle fuselage. which is known for having tiles fall off due to condensation. The shuttle tiles didn't fall off during re-entry. That wasn't the problem. The shuttle tiles started coming off with water, with condensation. When the shuttle came back down, or when they first delivered Columbia in '79 to KSC, right? They flew into Florida's tropical atmosphere, or tropical environment, right? Florida's tropical. It's humid. Anybody that lives in Florida, it's a little humid. And what happened is the shuttle tiles started absorbing the moisture out of the atmosphere, and the water was basically a solvent for the glue that they were using, and the tiles just fell off. Now, how does that deal with this? Well, this thing, their proposals were for it to take off from Florida, right? With hydrogen inside and spray-on foam insulation, right? Now, just because you have spray-on foam insulation, does that mean that ice doesn't accumulate on the vehicle somewhere? No. The SLS core had ice on it, on the inner tank, where their reliefs on the inner tank, there was cracking of the foam, right? Now, don't get me wrong, this isn't an SLS stage, right? But also at the same time, anywhere that the foam cracks, you're gonna get moisture through, and the moisture is gonna hit the glue on the backside of these tiles. You're gonna get condensation on the backside of the tiles. So now you're running into the same exact problem that the shuttle had. The other solution was a metallic thermal protection system. The metallic TPS probably would have been the way to go with this thing, because that, I can tell you right now, based off of what we know. Now, don't get me wrong, I'm not saying there's a way that this would never work. There's probably a way to figure it out. Tough rock would work. Tough rock and a mechanical adhesion would work, but then again, you're mechanically adhering the tiles to aluminum, which aluminum still expands and contracts, so they would pop off, right? So the metallic thermal protection system probably would have been better, but that would have been absurdly more expensive than this. Yeah. How in God's name do you know all this stuff, and why are you not working for NASA? I can't just go to NASA and do a Ken in the Barbie movie and say I played Kerbal Space Program, so I should work on spacecraft. I'm pretty sure they'd be like, nope, go away. Are you a doctor? Can I be a doctor too? Nope. Can I speak to a doctor? I am a doctor. Well, I want to be a doctor too. Can I just do one appendectomy just once? Nope. You can't. You're not a doctor. So, go figure. I do wonder if Star Raker would have been able to mitigate the need for so many different tiles, since it has more flat areas in comparison to the shuttle and seemingly more consistent fuselage. Rocket Guy, yeah, I think they would have gotten around this problem because Star Raker is literally, when it's empty on fuel, it's literally a freaking big fairing. Like ballistic, really low ballistic coefficient, high coefficient of drag. Like this thing could just glide around in the upper atmosphere. You would be great working at the visitor complex at Kennedy Space Center. Yeah, Tyler, that'd be fun. I think I would talk people's ear off too much. I like getting into nitty-gritty. I like getting into this stuff. Tough Rock wouldn't have worked at the time. It wasn't a thing until 2012. Yeah, exactly. Yeah, I mean. So long story short, this entire project reeks of like insane complication. This would have been hard to do. It would have been hard to make. Like extremely difficult to make. This would have made engineering the space shuttle the most complicated launch vehicle ever devised, maybe save for Buran Energia, right? This would have made that probably look like a Mercury capsule, like in terms of factors of difficulty. This is no. One of the docents at the Varhesi Center tried to recruit me. Yeah, Hellfish, that's happened to me too. I can't tell you how many times I was walking around Intrepid and the docents heard me saying stuff and they're like, you should work here. And I'm like, what? They're like, you should work here. You really know what you're talking about. And I'm like, you gonna pay me? And they're like, well, it's all voluntary. I'm like, I don't live around here, sorry. If I lived in New York, I probably would be like, yeah, absolutely, let's do it, man. But I'm like, I don't live around here. A new Kerbal challenge just dropped. But the Saturn V, though. Saturn V was hard to make, but I think the space shuttle was more difficult. The new Kerbal challenge is a rover replica. Cool. Neat. You should work here for free. I'm like, I mean, geek. Here's the thing, dude. That you want to get into a museum and you want to do stuff like that, that's how you start. You start kind of volunteering your time, and then if you really know what you're doing, they'll bring you on. That's how museums mostly work. You know, that's how most things happen nowadays, but it is what it is. 4 crew members assigned to launch on SpaceX's Crew 8 mission for a long-duration stay. That's at the end... Oh no, this is Crew 8. NASA astronauts Commander Matthew Dominic, pilot Michael Barrett, and mission specialist Jeanette Epps, along with Roscosmos cosmonaut mission specialist Alexander Grebenkin, will join Expedition 7071 crew members aboard the space station early 2024 to conduct a wide-ranging set of operational and research activities. Cool. Very good. Sure, but a man's got to eat. Yeah, exactly. Geek, if I had lived down the street from the Intrepid, I would have done it. I would have been like, yeah, let's do this. Sure, absolutely. I would have done that on the side. But the problem is New York's 3 hours away. I'm not commuting. I don't think even if I was making how much I make on the stream, for just doing that, I still wouldn't do it. That's a long way. And then you got to go down the Merritt Parkway. I hate that road. That road sucks. Somebody always crashes on that damn road. Hey, Ewok, what's going on? Like, if the museum was closer, I would have done it, no problem. Because J79s, dude. Actually, what the docent heard, the last time it happened, I was talking about the F4, and I was talking about the J79, the axial compression, the axial compressor on the J79, and why the F4 Phantom was designed to go so fast. And one of the docents, like, after I was done talking to, like, streaming it, the docent came over, he's like, dude, you serve? I'm like, no. He's like, how the heck do you know all that? I'm like, internet, baby. Internet's dangerous, man. And the guy was like, dude, you gotta work here. Like, one of the docents, he's like, I worked on J79s. You have to work here. I'm like, really? You want to tell me? You want to talk? You want to tell? I'm talking about J79. It happens. Some guy. Yeah, it happens. Dude, I love to live and breathe this stuff. Yeah, I was like, dude, let's talk. Talk to me. Talk to me, Goose. That's how you learn, guys. That's how you learn. And yeah. Was that the dude you got to talk about the start cart with? That was a different occasion, Tessa. I actually talked with one of the guys that works in the restoration hangar about the start cart. I'm like, give me 5 minutes. Well, I didn't say give me 5 minutes. I said give me an hour and I'll rebuild those 2 Hollies and I'll bet you we could get the start cart going if you really wanted to. And they weren't very keen on it, but I was like, I could absolutely get this running right now. We could start the start cart. They were like, I don't know, maybe. I'm like, I'm serious. There's an auto shop down the street that has the carb rebuild kits. I'll buy the kits. Let's do it. And they were like, no. I'm like, you don't want to start the start cart? All right, whatever. Why does the F4 wing design look so weird? The F4? The F4 has these dihedral surfaces here and anhedral control surfaces here, basically to make up for the fact that it flies like trash. I mean, I'm not gonna lie, they look awesome. The F4 is one of the coolest looking jets around. It doesn't get cooler looking than that thing. But if you look at this right here, if you look at this early concept from an F4, you can see that it has completely straight wings, and then the stabilizers in the back are completely straight as well. Basically, they had to put the wings down like that because it was something with the aerodynamic flow over the fuselage. These wings, when they're straight up like that, they don't get any air, so the plane doesn't fly very well. The F-4 is proof that even a brick can fly with enough power can fly. Yep. Looks like they're getting ready to go over the second spin prime test. Cool. So yeah, they had to go dihedral with the elevators and anhedral with the edges of the wings. Static fire is less likely, but not entirely out. It's a shame, because the F4 is a beast mode of an airplane. Maybe if they gave it a tail similar to like a C5 or something, then it probably would have been better. But it's not Kerbal, guys. You can't just move the control surfaces up here. It's not that simple. Like, that would require an entire structural redesign of the fuselage to be able to support all the stuff that you need for the deflection for the control surfaces up at the top. So their solution was literally just make them anhedral. But you got to understand that the F4 wasn't really designed to dogfight. It's not very maneuverable. But it doesn't have to be maneuverable. The F4 is literally just designed to go fast. That's it. It's just designed to go fast. Static fire is Sunday? Cool. Sunday? Ah, damn. Yeah, exactly. The F4 was designed under the impression that missiles would do all the fighting and dogfighting, and dogfighting wasn't ever going to happen again. Bingo. They didn't even give it a machine gun, guys. No machine gun. No machine gun built into the design. And then they went to Vietnam and they started fighting, and these things were getting shot down by 20-year-old MiGs with machine guns. That also has to do a lot with pilot training. The pilot training during the 60s was atrocious. It was very bad. That is the reason why Top Gun exists. The Naval Weapons Training Program, Top Gun, like the movies, there's a reason why that exists. That exists because not only did our pilots not know how to dogfight, but they didn't have the tools to do it. Because we never taught them how to. The reason why we never taught them how to is because we didn't think we needed them. So they would shoot Sidewinder missiles at a MiG, right? Get a lock, you'd shoot the Sidewinder missile, and the Sidewinder missile would just go that way. It wouldn't lock, it would break. And then now you're in a dogfight with another plane. They have machine guns, you don't. So you either have to get away fast, which doesn't always work. I mean, even with 2 J-79s out back, that's not really how that works all the time, right? Sometimes you get in too deep. It's really easy to do that with target fixation and lack of situational awareness, etc., and basically not teaching people how to dogfight. That's really, really a big thing that can happen. It's Gran Turismo drummer. I'm keeping it low in the background, so yeah. But yeah, that's... Give it a little bit of volume there. But yeah, that's the idea. I still think the F4 is one of the coolest looking planes around. That thing, it's a cool looking plane. It's not the best. The F-15, the plane that superseded this from the same company, is literally better in every single way. But the F-15 exists because the F4. The F4 crawled so the F-15 could walk. And then there's the British version with the Rolls-Royce engines in it, which is actually really cool. I don't like DC-10s. Caps lock. Tri-stars are where it's at. Kill it killed the TSR-2. Yeah. I was just looking at some of the original designs of the F4, and I'm like, why did they switch the wings like they did? Are you serious? I just told you that a moment ago. Anyway, back to Star Raker. So yeah, Star Raker ended up... I said I would explain this at the end of this. Star Raker ended up not becoming a thing because the oil crisis in the United States ended in the late 70s, early 80s. So because the oil crisis ended, there was no need for something like this. It's too complicated for what we were trying to do. Now, here's the interesting thing. I've been sitting here saying that Star Raker is nuts. This idea is nuts. There's complication in this project that is ridiculous for trying to build. Like, for instance, putting bilobe fuel tanks inside of your wings. That's absolutely insane. Now, I want to point out, this is important to understand. It's insane. And when I say it's insane, I don't mean that it's impossible by any means. You could do this. Sure. Absolutely. You could do this. Something like this could be made. Star Raker, there's no technical limitations to Star Raker. If I had to guess the biggest technical limitation, there would have been two. And it's always around propulsion. And with any rocket, it always is. Air starting RS-25s would have been something weird. Because those are supposed to be shuttle engines in the back that are air started. That would have been a hard problem to solve. Air starting any rocket engine is really absurdly difficult. But I suppose it wouldn't be too bad because you have the jet engines propelling you. So getting like tanks to settle and stuff wouldn't have been the biggest deal. The other ridiculously hard problem to solve would be the actual jet engines. Intercooled liquid hydrogen turbo ramjets. It's doable. It would require a ton of propulsion research. I guarantee you, with this, honestly, building the airframe for this would probably be the easy part. The propulsion systems, it's always propulsion. That's the hard part. I want wings that go like this, not like this. Do you think Star Raker would have deflecting tips like the Valkyrie to give it more lift, especially in higher Machs and elevation, or do you think it has enough charge with its wingspan? I don't know enough about aerofoil design, Seakraken, to really say one way or the other. I'm pretty sure that the Valkyrie has those dihedral wing surfaces on the outside just to look cool. With that being said, I will default to Rockwell's airfoil design. I think that whatever was designed here is sufficient. I mean, like I said, this project was good enough to get... It was good enough to get some preliminary analysis done. So they started basically doing the math. Long story short, they started basically doing the analysis to figure out like how much thrust they would need, you know, how they're going to design it, what parts are going to be used. Basically, I wouldn't say they got to a CDR, but they got to a preliminary design review. And what does that mean? So, in NASA's systems engineering book here, I have a paper copy of this book. Here. I don't know why it didn't auto-populate. Here it is. It's a little ways in here. Give me a second. It tells you about the different phases of projects here. An overview of system engineering project phases. So it looks more complicated than it is. Basically, they got past pre-formulation here, and they were basically in formulation, phase B, PDR, and technology completion. Long story short, this is thinking about and designing the plans for what you're going to do, and then this part down here is actually going and building it and testing it. That's like systems engineering or project engineering per NASA's manual is two big parts. The first part is figuring out exactly what you want to make. And the process for figuring out exactly what you're trying to do and what you're in systems engineering it's called stakeholder expectations. Figuring out what you're trying to do. That is a huge part in any type of engineering. Software engineering, big time. Mechanical, electrical, aerospace, which is literally a combination of all those things nowadays. Figuring out what you're trying to do and what you're trying to make and getting everybody kind of up to speed on that is a big part of this. So they definitely got to, it's either phase A or phase B. I'd have to read. Let me refresh my memory. To determine the feasibility and desirability of a suggested new system and establish an initial baseline compatibility with NASA's strategic plans. Develop final mission concept, system level requirements, needed system technology developments, and program project technical management plans. To define the project in enough detail to establish an initial baseline capability of meeting mission needs. Develop system structure and product requirements and generate a preliminary design. Yeah, they got to phase B. They got to phase B formulation. End products in the form of mock-ups, trade study results, specification and interface documents and prototypes. That is exactly what this is. What this document is. Phase A, you'd say, Rocket? I mean, they didn't build any mock-ups, so interface documents. Yeah, so I would guess somewhere between A and B. More on the A side. He said moron. You're probably right in that regard. Some guy, it would have dropped 3 out of 4 of the main landing gear bogies, because you need all this landing gear to hold that up. So this set of gear, and this set of gear in the back would have been jettisoned. Believe it or not, in Kerbal, landing gear doesn't have very high mass. It's a very, very low mass subassembly. Long story short, I'm not jettisoning the gear. That would be too complicated for Kerbal. I'm making a design change there. I'll just basically make it so when you land, you don't need all 4 of these gears. Phase A ends with a strawman baseline concept, which they definitely had. But it doesn't sound like they really went much further to reduce risk and validate design point decisions. Yeah, I retract that. I think you're right. It would have been more phase A. But yeah, they didn't even really get to PDR now, did they? Wait, where's CDR in this? Hold on. Yeah. Okay, CDR is over here. So there's concept and design. They basically got like right around here, about 15% of the way completed. When I have a moment, I think you like the pics in the PMs that I sent on Discord. Azimuth thrusters. That's cool, man. Neat. That's cool, Shy. The more I see in that design, the more complexity I find. That's slick that they seem to have gone all out. I mean, I'll say it once, I'll say it again, man. Star Raker is not infeasible. There's nothing in physics here that says that this can't be done. There would be hard problems to solve. And I'm not sure that something like Star Raker would have ever gotten to the point of flying once a day. You would need a lot of you'd need a lot of development money, and you would need a long time. And you would, not only would you need a long time, but you would need to keep up a pace of rapid iteration for a very long time. Basically, a SpaceX-like Herculean effort here. It would have been hard to do. Like, this project is Starship level complexity. Actually, I'm not even sure. Yeah, I would say this is like a Starship Starship, Saturn V, probably more complicated than all those and the space shuttle. Like, this is like probably about as crazy as you can get for spacecraft design. A lot of, yeah, and you would have had to keep that effort going for decades. This would take decades to get this right. Yeah, decades. This would, yeah, I can safely say that this would be more complicated than the space shuttle. Probably the Saturn V too. Buran Energia. I would contend to say that this is probably more complicated than Starship 2. But Starship doesn't have vehicle complexity. What makes Starship so ridiculously complicated, like what puts it over the top, is the launch pad. The remote reintegration of the vehicle. That is so ridiculously ahead of its time. Like, that's some next level stuff. I seriously don't think people consider how absolutely nuts it is that they put the rocket together with no humans near the rocket. Like, literally what we were doing in KSP, remotely operating a crane and putting the vehicle together, that's crazy. I would say that Starship, if you're comparing vehicle to vehicle, I would say that Starship is probably less complicated than Star Raker. But the entirety of the Starship program, GSE included, fabrication and everything probably is more complicated than this. If you're comparing vehicle to vehicle, I would say that this is more complicated. But, you know, overall complexity, it's Starship level. You would need Starship levels of effort to get this done right. The operational complexity would have been insane. Like, I mean, Rocket Guy, in Hayes Gray Art's video, he showed this thing being aerial refueled by a KC-135. So first of all, aerial refueling cryogenic propellants. How are you gonna do that? How are you gonna do that without a purge flame? Like, okay, so there's that. In contrast, though, we were staring down the barrel of not being able to provide basic necessities for the majority of the country, so it makes sense we'd be willing to do it. Desperate times for desperate measures. I mean, I'll say it once, I'll say it again. There's nothing here saying this can't be done. Like, people look at Star Raker and they say that's insane. And I think people get that confused with... Like, people say, oh, that can never happen. This is too complicated. It's not that it's what they... When you hear engineers say that, oh, it's too complicated, it's one of two things. Either there's probably an easier way to do this, or it's not that this can't be done. Anything can be done with engineering. Anything. It's just, this would take a lot of time to get it right. But I will say, if this thing ever got to the point where you could take off from a runway and deploy 100 tons of payload, come back down and land back on said runway, refuel and reload the vehicle like a 747 or something, then I will say that would be a game changer. That would open up the door for pretty nutso stuff here to be built in space. However, with that being said, you could make the same argument with the space shuttle. Heck, you could make the same argument with the Saturn V. And that's what I mean. That's what I mean when people say, oh, there's probably an easier way to do it, right? So this thing launching every day would be pretty damn useful. The shuttle launching every day would be pretty damn useful and probably a little bit easier to do. It would probably, I would say operating the shuttle would be easier than operating this thing. And that's kind of nuts considering what the only thing you're supposed to do here is just refuel the thing, but... Same argument with Falcon 9. I would say that Falcon 9 would be easier to operate than the shuttle on a daily basis. It's nowhere near as complicated. This Skidoo Polar once around is pretty easy. By definition, Star Raker would be less complex to operate. Yeah, by definition, Hellfish, but I'm looking at some of the things here. Star Raker would have to go through the same... looking at the tiles, the tile cross-sections, if they decide to go with the RSI tiles, Star Raker would have had to do the exact same thing as the space shuttle. They would have had to go over every individual tile and re-inject some of the sealant almost after every flight. The shuttle has 30,000 tiles on it. This thing is 3 times the size of the shuttle. If it worked as intended, then yeah, this would probably be easier, I would say. But like I said, this is taking the shuttle and the external tank and a C5 Galaxy and an SR-71 and combining them into one thing, which... Okay. No foam strikes to deal with. Nothing stopping them using much bigger tiles. You think they wouldn't? I would go with the metallic option from the Stardock Deluxe, but then again, these concept designs are from 1978, before they realized the tiles started absorbing water, so... We have the benefit of hindsight, I suppose, in that regard. Alright, anyway. You know, I just put these in here to kind of show, but I think working on tank design right now might not be the worst idea. Oh yeah, did you see this? Varda did some LK99 stuff. Yeah, with the magnet, getting the thing to point upright. I did see that, yeah. Anyway. Was this thing supposed to deploy cargo through the hinged nose as well? Yeah, Jim, that was it. It's supposed to do that. To deploy in space and on the ground. One payload bay mechanism. Actually, getting that all figured out probably is something we should figure out. The purge for the in-flight refueling could have been through the KC's engines. A hydrogen purge flame through the combustors. I mean, you're right, John. Yeah, that could do it. But that's a whole level of now you're redesigning a KC-135 as well as engineering this vehicle, right? Like I said, there's nothing saying that it couldn't be done. Just like there's nothing saying the shuttle couldn't have been made to fly on Falcon 9's level of flight rate. I still think that. I still think that the shuttle could have been made to be as reliable as Falcon 9 is now. In fact, Falcon 9 is doing what the shuttle was supposed to do. I disagree. Do it through Star Raker's engines. They're already burning H2. Probably a better idea. Yeah. That's probably a better solution. All right, let's get back to this. All right. Some things that we should probably work on today, dudes. We should probably... I don't know. Should we... I actually... You know, I was just doing this to show Rocket Guy that, but I don't mind that tank placement. And that is the thickest part of the wing. We ended up doing... Basically, kind of, these are called bucks. Basically, we kind of use panels to trace the profile of the wings in certain areas, just to, you know, get the shape of the wings figured out. And keep in mind, these are just the final. These panels are not going to be there in the final design. It's basically my template. The only parts of the vehicle that are here that are going to be in the final design is basically the fairing fuselage right now, and the landing gear. And even then, those components are in flux. Like, I'm not. Yeah, I think maybe building the aero shell would be a good idea. It's starting to build out the wings and whatnot. That would get us building out here and kind of finalizing the forward mass of the vehicle would probably be better for a final balance. That would help me with my tank's positioning and stuff. There is another big line item here, our propulsion systems. Guys, I mean, we could just shoehorn a bunch of whiplashes back here, but it seems like all the engines are at the very back of the vehicle to balance something out, similar to the space shuttle. Thanks, Ducky. I was thinking during the loitering waiting for hookup, you're going to need to purge the whole time you have cryogenic fuel. Yeah. I learned an interesting fact earlier. Landlocked Pittsburgh, Pennsylvania has 446 bridges. Venice, Italy, the city built on water, has 443 bridges. Brooklyn, New York, a literal island, has a mere 27. Why does Pittsburgh have 3 more than a city literally built on water? Because to imply that Pittsburgh is landlocked is a little ridiculous. Pittsburgh is built on a confluence of 3 rivers. Pittsburgh is not landlocked, not even close.
Discovery, go at throttle up.
It's not near the Great Lakes, and it's not near an ocean, but it is definitely not landlocked. See, Pittsburgh is built on a confluence. It has so many bridges because there's the Ohio River. I'm going to screw that. The Monongahela River. And what's this one? Sorry, Pennsylvania people, I don't know the rivers' names. The Allegheny River. Yeah, this is the confluence. That's Duquesne Point. Like, Pittsburgh is built where these 3 rivers converge, and the Ohio River goes basically. Okay, I gotta follow the Ohio River for a second. I don't want to guess. The Ohio River is a big river for what it's worth. Let me just put it like that. Where are we? Yeah. And it flows in. Yeah, it flows into the Mississippi. That is not anywhere close to being landlocked. It's not like Columbus, for instance, which there's a couple of rivers here and there, but yeah, Pittsburgh has a lot of bridges because it's at a confluence. That's what that's called, where these rivers all join. There's another city on the other side of the country that's built around a confluence. Portland. The reason why Portland, Oregon exists is because of it's where the Columbia River joins up with another river and then goes into the ocean. Yeah. Remember, boats were the only way to move around for a long time. That's why inland cities weren't really a thing until the railroads came around. For testing purposes, maybe fill the wing space with tanks to see what kind of mass we're going to deal with. I think we can do that too, Tessa, yeah. But I don't really have a shape. Like, that begs the question. Do we make the wings around the tanks, or do we build the wings and then try to fit tanks in? I mean, obviously, I'm not going to lie. I made this to fit 2.5 tanks in here on purpose, because that seems to be kind of the case. The interesting thing about this is that the more and more I look at this, Tessa, the more I see the space shuttle. They definitely took a lot of design cues from the shuttle. For instance, shoehorning all your engines in the very back of the vehicle. Delta wing design. Payload bay in the center. Propulsion systems in the back. Right? But the thing about Star Raker is that Star Raker has to have the external tank in the design.
The thing about Star Raker.
Oh, the thing about the Star Raker. Brimo's here. What's up?
Hey.
How you doing, baby?
Good. How are you?
Turns out that building this is a little complicated. That's
No,
basically that's the point.
Building fake airplanes is complicated?
Why don't you just take me down a peg or two, lady?
Can I talk to you for a minute?
Yeah, alright. Give me 1 second. Give me 1 second, chat. I'll be right back. Wait, am I in trouble?
No, you're not in trouble. You're
Okay,
never in
cool.
trouble. Whenever, like...
Okay, cool. I'll be right back. Alright, I'm back. Where'd the music go? Oh, there it is. Okay. Yeah, anyway, river confluences, man. Creeper, that's why there's so many bridges. It's because the three rivers come together. In fact, yeah, Pittsburgh's baseball stadium where the Pirates played until they had PNC Park was called Three Rivers Stadium. What chore did you get from Bremo? Oh, nothing, actually. Yeah. What I do is put the tanks in dragless fairings in the wings, then build the wings around that. It gets you more of a realistic drag profile. Well, Tessa, yeah. I mean, I'd say tank design would probably be the right move. Yeah. And as long as we're working within the bucks that we made out of panels, I think that's good enough for the wing tessellation to make it do. Yeah, let's work on tank design, and then after tank design, after we do tank design, we'll start building out the forward components, because there are components up here that absolutely need to be here. We need the hybrid tech systems, and we need the locking tech. We need the locking systems for this. That is something that we absolutely need. The vehicle is useless without it, so that's something we got to figure out. I actually got to figure out an interesting new piece of hybrid tech here, because I noticed during tests with the small model and tests with this, the hydraulic here is extremely susceptible to torsion. Basically, when you take the cockpit and you kind of move it off to the side that way, the thing likes to twist. So we're going to need to come up with some type of new hybrid tech to hold that hydraulic in place. Not insurmountable, just, yeah, new hybrid tech. Shouldn't be too bad. But Primo know that the VW bus is still up for sale in my area. I remember she wanted the VW project. Yeah. Were you really in trouble? No, not in trouble. No. Primo was just telling me that she was going out to the shops. This is gonna be tail heavy. Can you compensate? Cirrus, yeah. Like I said, this is what I was saying. This is basically a gigantic space shuttle. The wings are an extremely similar design. They're very similar. I mean, the wings are overhead, so it's a little different, but you can see that they took a lot of influence from the space shuttle with this design. I mean, obviously not just the main engines and whatnot, but how about one panel on the front piece sandwiched between two other panels on the back part? All you need. I would prefer physics-less parts, Aqualex. What I was thinking, sandwiching it is obviously the right idea, but hybrid tech really favors physics-less. So I was thinking that. Using modified spectro
Discovery,
design. Like this. Either that or just building landing gear that's good enough to hold this thing up. You know? You know, we could do a side deploying landing gear like the Super Guppy did. The Super Guppy used its... But then again, there's no main front landing gear here. So maybe a secondary set of gear here might be the right idea. From a KSP point of view, how do you skin the wings in a way that doesn't decimate the lift profile? This is a problem I run into all the time. Well, some guy flying... So we have a benefit here, okay? The benefit here is that we have a gigantic wing surface. The wing surface is huge. If you can't get something to take off with wings this big, yeah, you didn't do it right. So, with something like Star Raker's engines are turbo ramjets. Basically, they operate like regular jet engines down low, but when you get to a certain speed at a certain altitude, the ramjet takes over and starts going like crazy. I know a lot of you guys are saying like, oh, well, EJ, what about the drag? Well, what about the drag? What about the drag? Well, the points of the regime, the points where we're going to be flying, right, closest to the ground, we're not going to be going fast. This thing is basically designed to U2 all the way up into, not all the way up into space. It's designed to work on a similar operating principle to a U2, meaning that it doesn't go very fast when it's down low, right? It doesn't go very fast. No faster than, I mean, okay, so let's look. It's going 0.85 Mach at 20,000 feet here on it when it's cruising. Take off and climb to 20,000 at 0.85. That's basically a commercial airliner. I mean, a commercial airliner doesn't go 0.8 Mach at takeoff. And there's no doubt that this thing is going to need a very long runway to take off. We have a long runway in KSP, so I'm not too worried about that. So the idea is that this thing basically flies subsonic until the start of the air breather climb. What it does is it'll start climbing, pushing the turbofan element of the engines, basically their absolute maximum. And then at 45,000 feet, it'll do a dive. It'll start to go into a dive. The dive will turn on the ramjets. For us, we need to do this around 7,500. So we would need to basically climb to about 8,000 at subsonic speeds, which I already proved that we can do with the K90. It's doable. Now, what's the K90 here? Let me show you. So basically, even with wing surfaces close to flat, right into the wind, because of the overall lift from the other surfaces being so high, it won't matter. Well, it does depend on how we build our airfoil, some guy, because when you build it out of a bunch of compartmentalized wing surfaces, how you place it, now you're getting into what's called airfoil design. So check this out. Look at the K90. It's going to be similar to this. The K90 is made out of a bunch of smaller wings in Kerbal to make a much bigger wing shape. And then I made the leading edge of the wings out of fairings. I don't think I'm going to necessarily do exactly that with Star Raker. I think we can come up with better solutions here. But if we have to do that, we can. The wing leading edge is made out of, well, fairings. The problem with this is that you get pretty bad side slip with this. But it's okay. So now, how you sculpt these wings, you're basically sculpting the wing into a giant airfoil. So think of this area that's highlighted right here. Now it's one big wing that we're taking multiple sample points from. Now, don't get me wrong, it doesn't work exactly like this, but you'd be surprised. You can get it to work pretty well. This design, you'd think with the engines on the top being above, very high above our center of mass, you'd think that at speed, this thing wants to nose down. The opposite. It wants to do the opposite. Because of the steep trailing edge on our airfoil here, it actually wants to nose up. This thing actually has positive pitching moment problems, the K90. Yeah. The reason why is these air surfaces, right? And now, don't get me wrong, the game doesn't understand this, but it doesn't understand it for the right reasons. So Kerbal thinks that these are being exposed to laminar flow, just air is flowing through the wing. It doesn't understand that the panels in front of it, the wings up in front of it, and the fairings are pushing the air out of the way, right? It doesn't understand that. What's happening here is that these wings are getting exposed to oncoming aero, and they're working like a spoiler. They're providing downforce, so to speak. But in my airfoil design here, that ends up working in my favor. Why does that end up working in my favor? Well, it ends up working in my favor because in reality, what would happen here is that you'd get flow separation off the back of this thing. You'd get huge flow separation here in real life. Basically, the air wouldn't want to make this steep turn up. It would just basically separate off the laminar flow of the air over the surface would basically go down. It would just separate right here, especially at higher speeds. Higher speeds, right? Now, couple that with the extreme high pressure coming off the back of the engines over here and a relatively flat surface. That's extremely high pressure up here and extremely low pressure down here. That's going to create a force that's going to pull the back of the plane down, kind of like a blown diffuser in Formula 1. That's how this works in real life. And in Kerbal, I was able to fake it enough to make that actually mimic that. Like, it mimics it for the wrong reasons, but hey, whatever, it still works. This does what it should do in real life. In real life, you'd get insane flow separation right here. And the air would probably just go up and wrap around and swirl off the tail of the plane, right? Couple that with the high pressure turbulent air coming off of this, and yeah, it's going to make the plane want to nose up. I understood and realized this from Boeing's X-48C project, which is what this plane is based off of. And if you look at the X-48B and the X-48C, same idea. It's the same design, and it's the same idea,
Discovery, go and throttle.
but the fluid dynamics in real life, right? Kerbal, I basically fooled Kerbal into making it think it's a fluid dynamics simulation. It's not. It's not fluid dynamics. Kerbal is not that complicated of an aero sim. If it was, we'd be paying a lot more money for it. But see, look at the X-48. Same exact idea, see? the back end goes up, and this works like a diffuser, and that actually makes the front of the plane want to go up. Crazy, right? Hey, Maverick. So Kerbal, I made Kerbal understand the aerodynamics here with some trickery, right? Making a wing out of a bunch of smaller wings so we could get the sample points on the wing right. In this regard, Kerbal works a lot more like another type of aero simulation. If you make one big wing surface and have a bunch of points of sample off said wing surface, it works much more like what's another type of aero simulation called blade element. It's called BET for short, blade element theory. Blade element theory is a type of aerodynamic simulation using a bunch of different variables to simulate, well, fluid dynamics aero simulation on a wing. Kerbal uses a super primitive version of this. But see how there's all different points of sample on the wing? So I'll give you an instance. There's velocity theta right here, right? And velocity beta. Velocity theta is the angle of the wing being exposed to oncoming flow. It's the angle of the wing, right? I'm pretty sure that's what that is. And then there's 2 pi radius n right here. And these are all the different variables, the wing, lift, drag, etc., etc. If you crack RT real-time fluid dynamics, someone figures out how to do real-time fluid dynamics, they're going to make a lot of money. See? There you go. Yeah, some nice differential equations, right? I'm basically getting Kerbal to do a more high-fidelity simulation here. And don't get me wrong, it's not simulating blade element theory. No, it's just, if you have more points of sample on a wing shape, on an airfoil shape in any simulator, right, there's more points of sample, right, then you're going to get a more comprehensive simulation. Just for, food for thought. Keep in mind, once again, this is KSP. KSP is not real life. Okay? KSP is not real life. Just because the K90 exists in KSP doesn't mean the K90 could exist in real life. But also, it's based off of stuff that could possibly exist in real life. This was a remote... The X-48 program was a remote control X-plane that Boeing and NASA was working on to try and make blended wing airliners. The idea is that if you basically take an airliner and get rid of all of its wings and control surfaces, right, and make the entire shape into a gigantic blended wing. Now, this is not a flying wing, it's a blended wing, okay? So, basically, the fuselage shape and the wing shape are kind of blended together to make it much more fluid. And instead of the jet engines being on the bottom, they're up on the top, right, to get that clean air, right? I mean, you could put them on the bottom, but the idea here is that with this gigantic blended wing shape, at subsonic speeds, it's way more efficient. The plane's way more aerodynamic because you have much less turbulence coming off the fuselage. I bet you it'll be a quantum computing win. And Aqualex, all I'm going to say is that superconductors would be really nice for quantum computing. That's all I'm saying. So yeah, some guy in that regard. Now, the next thing that I've done, the next thing that we're going to do, that's the wing shape. So I can get it to work within reason how something like this would work in real life. You can get it. I could get it close. So the other thing is the fuel tanks, the question of fuel tanks in the design. Now, this requires a little more trickery. Little Kerbal trickery in my bag of Kerbal trickery, I guess. To understand this, we need to look at this thing right here. So, LV5B1 Block 1, that's the SSTO. So, I did something with the SSTO to make it fly how a lifting body would fly. That's why a lot of the components are made out of panels. It's kind of a mix between panels and wings. Because with a lifting body shape, not all of it is generating lift. Some of it is generating drag. Turns out when you make something that's shaped like a big wedge of cheese, it doesn't fly very well. But it will fly. Anything can fly with enough thrust, right? And I think we have enough thrust on the back of this thing, just saying. Now, the fuel tanks are the key here. If you look, in here, there's a fairing. My fuel tanks are inside. The center of mass of each one of the fuel tanks is inside of a fairing. Now, why? Why would I do that? There's 3 big ones. Because the Venture Star and X-33 designs were supposed to have a hydrogen tank here, a hydrogen tank here, and then a LOX tank up in the nose, right? And then the back section here is all propulsion, but that's another story. What I did was I used the hierarchy and hierarchy aerodynamics to put the fuel tanks in a fairing. And the way I have this set up is that the end of the hierarchy is right here. So the fuel tanks don't actually make drag inside. They don't make drag inside of the fuselage. The only thing that's making drag here is the fuselage itself. The drag from the fuel tanks is actually applied at the back of the vehicle, where the hierarchy ends. We're going to have to do that. We have to do something like that. That's why I redesigned the fuselage the other day. I redesigned the fuselage on the Star Raker itself because we figured out some logic with the fairings. I don't have the prototypes loaded into this save, Hellfish, but yeah, the tanks are all shoehorned in here. And I know what people are going to say. Like, if you're looking at this and say, oh, you clipped the tanks? Oh, that's lame. Well, first of all, mimicking liquid hydrogen's fuel density is a little bit hard to do when you only have liquid fuel and oxidizer. Second of all, the fuel tank, I have stuff clipping in, but there's also a lot of open space inside of the fuselage here. If you look up, all this aggregate open space, right, is where a potential fuel tank should and could and would be, right? So I basically do an approximation of, like, if you clip fuel tanks together, make sure that the fuel tank is occupying a space where the clipped area equals the total volume of the clipped area with fuel tanks equals the total volume of the area that the fuel tank is trying to be put in. Basically, I'll clip 2 fuel tanks together if there's sufficient area around it that would basically be area where we would fill the areas that the clipped fuel tanks are together. That's kind of my rule. But yeah, some guy will do that with Star Raker, and we'll do the tessellated wing design. We'll basically combine build methods what we learned from the SSTO, from the K90, and also the shuttle build too. So that it's realistic volume-wise. Exactly, Ducky. That's my rule for clipping tanks. If you can clip tanks together, but make sure that the 2 clip tanks have some basically breathing space around it where that fuel would eventually go. We're limited in fuel tank shape because we only have cylindrical tanks, right? But that's the idea. And then, yeah, also we'd learn from...
Discovery, go at throttle up.
We would learn from... the shuttle build, which is here. Thanks for the explanation. No problem, dude. Don't mind the other parts of this. This shuttle is carrying an experiments package for propulsion systems. But, yeah, see? See, the shuttle wings are made... I made them up out of panels. The panels actually simulate the heating here. The shuttle TPS is one of the things that I'm actually the most proud of that we've ever done. There's a crack and drive in the payload bay of the shuttle. So I had to take off like the one from Cowboy Bebop. Yeah. 1C is the actual stack. But yeah, if you look at how we... If they could change one thing with KSP. I would really wish it would be fairing transparency. But it's okay. Yeah, see the tiles on the shuttle? We're gonna have to do stuff like this with Star Raker to get that wing foil to actually work how we think it's going to work. Yeah, see that? That was one of the most difficult things that I've ever made in this game. The strakes. My shuttle strakes. You see how crisp that thing is? The panels are actually helical. If you look at this thing from the side, it looks like the panels are just completely straight. But if you look at it from the front, check that out. That right there, like I said, is one of the most complicated things I've ever made in KSP. Now, I know what people are going to say. What do you mean it's the most complicated? That's super easy. It's not as easy as you might think. These panels are rotated. Each panel has a slight offset rotation to it to get that helical shape of 2.5 degrees exactly. Basically, I was moving panels around on increments that are not in the editor. I had to invent my own tools to make this because the editor only moves stuff around in 5-degree increments. We needed 2.5 to get this right. So I built a piece of equipment for the editor out of robotics called a panel tessellator that was able to mimic this shape for me. The OLM vent is venting a lot. Yep. Yeah, but once again, this shuttle is like, yeah. I wanted this thing to basically be KSP1's swan song because I wasn't sure when we'd be back. But yeah, that's beast mode. The panel tessellator, Jim, was one of the craziest things that I've come up with. And guess what? We're probably gonna have to use that build method to make the wings on Star Raker. I have the panel tessellator in my prototypes, in the prototype shuttle files. They're over here. Let's just try Proto 1. Let's see what that is. There it is. There's the panel tessellator. The panel tessellator was basically a system that I used to... Oh my goodness. Holy crap, dude. This is so next level, man. Yeah, there's your angle controller. Oh, the second sneeze didn't come. Oh, that's so annoying. So, Jim, basically what I did was... I used the length extender here to place the panel where it needed to be using numerical inputs here. So, like, you could figure out the position for each panel. And then I used a rotational thing to basically get finer increment of rotation. So, basically, if I wanted to figure out how this panel got there, like how to place that panel, you'd punch in a combination of numbers. So to get it to the right length, right? And then the datum extender is basically... The datum is there to basically double check your panel position. You would line it up to the edge of the panel. And then the rotational length extender... You say that's in the position right there. And then you'd use the angle controller to basically, you can get the rotation down to a degree, or down to 1/10 of a degree. So you could set it to like 1.2, or like, we could just go to 2 degrees. And for instance, mine is, I think we rotated them on a 2.5 degree increment. And this uses a little servo back there to get the rotation right. See that? That way you can make a complicated shape. You can use panel tessellation to make a helical panel design. So, you know, I would place this thing, rotate the panel a little bit, right? Find the position that the panel needs to be in, and then you'd grab a panel out of the parts bin here, place it on the structure, and then just manually rotate it in place so it started Z-fighting with this. And that's how I was able to get the shape. Hey, Urban, thanks for the raid. Kind of like a 3D printer for Kerbal. Yeah, but you have to manually place every part. And you don't need to worry about bed leveling either. Yeah, that's the panel tessellator. Seriously, one of the most hardcore design things that I've ever made. How's our bird looking? It's getting there. We're talking about ways to build the thing. That's really neat. You must have done this when I was away on vacation, because it probably took you a week. I built my Mark V orbiter, Jim. I had the orbiter finished in a week. Yeah, you must not have been there when I built it. Thank you for the shout out. No problem, Urban. Thank you for the raid.
Discovery, go at
Guys,
throttle up.
my buddy Urban Venture plays KSP as well. Pretty damn good builder. You know, if you want to support more Kerbal streamers, Urban's your guy. When KSP2 shuttle. When they put RT, I've kind of basically decided that when re-entry heating, when the re-entry heating gets into the game, which seems to be sooner rather than later, that's when we'll jump back in. I can pack a nice cargo bay too. There you go. So we would see how Starraker would be built if built by relativity. Yep. So yeah, that's how it came together to build that shape. It's one of the things I'm most proud of in KSP. The panel tessellator, man. I mean, once again, we're gonna keep going with that meta, right? But dude, look at that. That shuttle is. I'm usually not really proud of the stuff that I make, and what I mean by that is that I'm like, I can always do better. I always push myself to do better because we're not under any deadlines. Well, we were for a while, but you know, like, I can sit here and we can tweak with it and we can make it right. That's not really generally the case with engineering on aerospace projects in real life. You have to get it done by a certain time, etc., etc. So in that regard, I try to push myself because we don't have to worry about time and we don't have to worry about budget necessarily. And because of this, we have time to sit here and really make the system how we want. And with that being said, I'm damn proud of this. I'm damn proud of this shuttle. This shuttle is one of my favorite things that we've made because it works exactly like the real one. If you know how to fly a shuttle in orbiter, or you're a big shuttle fan, and you've ever seen me flying this thing, it works an operating principle exactly like the real one. It's a Kerbalized version of the shuttle in every sense of the term. Even the payload bay operations work exactly like the real one. I mean, the lights in the payload bay are in the exact same positions that the real shuttle is. All the thermal blankets are in the right spots, the flag's in the right spot, the docking port's in the right spot. I even blocked the door out on one side with a flag because the real shuttle doesn't have hatches on either side. The KSP-1 shuttle model does, though. See it right there? I blanked it out with a flag. No, I never uploaded the tessellator. No. But yeah, if we need to go and build, we're gonna need to do stuff like this with Starraker. It might get a little complicated. I hate that thing is kind of floating like that. And now I'm sitting there. But this is a prototype. This wasn't the final version, so I don't like how those are overlapping. But don't save. Let's go back to Starraker. I've never uploaded this shuttle anywhere hypersonic. No. I don't want to give it out. That's more of a blue law at this point. That's kind of my rule. I want people to look at this and see my panel tessellator and be like, oh, I can do that. I want to do that. With that being said, there's not many other craft files that I'm like, yeah, no, I don't want this. I don't want people to have this. I usually give them out. I don't really... The shuttle is the only one that I don't. My want there is for more people to go and make one. Anyway. Too much adulting. Yeah, I understand. My precious. Alright, fuel tank design. With procedural wings, KSP-2's shuttle will not take all that long, right? It depends, Nova. I really haven't gotten into building out KSP's, I really haven't spent too much time trying to understand KSP's arrow. The big reason why is that I can't. I can't understand KSP's arrow because there's no debug tools. There's no F12. There's no debug menu. There's no arrow UI. There's nothing. It's really hard to understand what the aerodynamics are doing just by looking at it. The reason why is because you can't really see air flowing over a wing without visualization. That would be like putting something in a wind tunnel and not using the smoke to see where the air is going in the wind tunnel. And then being like, yes, Peep OG. Frost is building on Booster 9. Cool. Let's just play around with fuel tank design now. Can we... I'm wondering if we could get away with this. Yep. Yeah, it seems to be the case. Nope. There should be a wind tunnel in KSP too, don't you think? I mean, Halo, the wind tunnel in KSP is hitting the fly button. If you shut budget off, you don't need to worry about the budget, right? Like, you don't need to worry about it. So... just hit the fly button. I mean, I suppose if you're playing, like, with hardcore rules, right? Like my mission mode rules from back in the day, then yeah, a wind tunnel would be useful. So going with the dragless fairings for keeping the tanks in the wing and only getting the wing arrow. I see about 40 parts in the fairings, then however many tanks you can stuff in. I don't necessarily want dragless tanks, Tessa. I want... I just want them to impart drag on the hierarchy in the right spot. And I'm not 100% sure how we're going to do that. I don't know, Nova. I don't really remember. That buck. This buck is in the wrong spot. That's more or less where it needs to be lined up there. If you think about it, these tanks would be inside the wing and therefore not generally adding additional drag other than the wing surface is what I meant. Now, Tessa, I know, but refresh my memory on how the dragless fairings work, if you would. How do those things do it? How do the dragless fairings work? The fairing makes no drag, but I don't want to just not make drag where drag doesn't exist by glitching the game. If the dragless fairings can in part drag somewhere else in the hierarchy, then I'd be happy with that. Then I'd be happy doing that. But if they don't, then I'm not really interested. I honestly don't think we need that many fuel tanks, but dragless fairings do add a ton of extra lift at the point of the fairing base, even though they block drag from all contained part nodes. I don't think that end tank mirrored. Yeah, keep in mind, guys, this is just, we're just messing around. Have you calculated how much gas is going to take into orbit? It's hard to do when we don't have an indicator of mass here, Jim. With that being said, 4487, here, I'm just going to use the shuttle engines. Let's just try to get a DV reading with the shuttle motors by themselves. 3856. That's too much. We don't need that much fuel. I'm pretty damn sure. Let's get this down to 3,000. That more or less is what we're looking for. Yeah, I know. This is liquid fuel and oxidizer that we're carrying, remember. And we don't even have the aft tank put into the design just yet. I mean, if we really want to go hard with this... What mass are we talking about? 800 tons. Links in the chat, Purple. 352. 3174. 2968. SpaceX is crazy. They detanked and they're just refilling again. Yep. Center mass is, with wings and all the stuff built into the front test, that's actually not looking too bad. This isn't bad at all. Oh, I forgot. We gotta drain these tanks here. It's picking up fuel from these tanks. I gotta get rid of that. That's messing up my calculations. 2911. I'm figuring about 3,000 meters a second delta V. I think that'll be where we need to get with the shuttle motors. See, I'm doing the ascent backwards. So it's very similar in like rocket design, where you design your upper stage first. You always go with the upper stage first. Don't design the first stage, because you don't want to finalize the first stage design and then design the second stage and then have to make modifications to the first stage because the second stage wasn't good enough. Or vice versa. So if we have a staging velocity of about 1100 meters a second, that's what I'm kind of aiming for. Pretty much, Rocket, yeah. How much are you planning on taking up for max payload? Oh, yeah. Well, the real one was supposed to do 100 tons, Tessa. So, if the real one's supposed to do 100 tons, you know, we're 62% scale, so let's say 60 tons. So, 2 orange tanks, give or take. 225 tanks. I'll always overestimate just to be sure. I mean, that's 72 tons, not 60, but we could get it right to where it needs to be. So 36. That's 54 tons. That's 58, give or take. That's about 63 tons. With give or take about 60 tons of payload. Funny thing is our center of mass actually falls into line pretty well. COM falls. Yeah, that's actually pretty good. 2746. That's with all that fuel, huh? Oh, wait a minute. I'm not getting a right indication here because that isn't connected to that. Or is it? Oh, no, it is. All right, cool. Yeah, that's right. Okay, so 2746 vacuum with just the shuttle motors. That's not good enough. Believe it or not, that's not good enough. We're gonna need a bigger boat. Celsius Shark. $28.41. 2943. This thing is freaking hefty, dude. $45K ISP is vacuum. It's close. It's much closer to vacuum. But if you wanted to see what I'm talking about, it's basically negligible to vacuum. You're only going to start to get really bad fall off when the pressure goes up to 101 kilopascals. But even then, we got shuttle motors at our disposal. We're talking about a 200 delta V difference. The last two tanks didn't mirror. Oh. Sometimes it just resets the symmetry. Either that or I do it out of force of habit. I reset symmetry to nothing. Thanks, Bucket. 3049. Or no, 3094, excuse me. It's not bad. Add another 50 tons for wing mass. You don't think that the I-beam jig is enough mass? That's plenty. There's no way my wings are going to be as heavy as the I-beam panel jig. Dude, that's kind of my route. That's kind of what I'm going off of here. This is supposed to carry some payload. Cosmo, the entire forward component here is a gigantic payload bay. Basically from here to about... See where it says cargo? From there to there. Huge cargo bay. Actually, we're under 1,000 tons. Not bad. This is, that's not bad. Yeah. But we still need to put some liquid fuel tanks in this thing. Lock off the tanks. Yeah. I'll tell you, refueling this thing is going to be a pain in the butt, man. Yeah, refueling this thing is going to suck. Yeah, it's going to be awful. I'll see if we can figure out a better combination here in the future, but this is more or less what we need. Looks like fueling is finished, so you might want to pull up the cameras. There you go. They already did a spin prime, Hellfish, and they appear to be tanking again here. So they might do another one. How does one refuel this many? If I remember from the concept photos, there's going to be mass produced, or at least more than one made. We're going to need a couple of fueling trucks, Ducky. We'll say we need a couple of fueling trucks and call it a day. I don't know if they're gonna static fire, guys. I think they're gonna spin again. Alright, so put that over there. Now, straight liquid fuel. I'm gonna start off with a Mark III, just to see what happens. Oop. No. I know that doesn't fit right there, but we'll... The launch mount looks slick with a fresh coat of paint. It's coming together, man. The pad will resist this time with the deluge system. Yeah. Hey, Pwn Sister. So, ooh, that TWR is awfully low. I'm just, yeah, test, hold on. I'm just placing the thing, dude. That TWR is not good. 0.12. I mean, it'll go, but I don't think that... We gotta push this whole dang thing up to, how efficient... I'm gonna go look. Like, what's my F4? Just out of curiosity. Yeah, 1.1. We don't need 1.0 TWR. It's not a fighter jet, you know? 0.12 is not the worst, but... Need to look at other planes. What about my K-79? .56. And this has 1,700 seconds of burn time. That means with the motors at max throttle, you'll run out of fuel in 1,700 seconds. What is the Star Raker, just out of curiosity? .3,100-second burn time. It's not the worst, dudes. The further we get into it, the more I think Star Raker Jr. would have been a good idea. Not sure how that helps me, but thanks. Yeah, they're all locked. That's it. 3,700 at 0.12 with 3,100 burn time. I'm just a little concerned about the TWR there. If we could get that TWR at like I'd say ideally like 0.5, then we'd be in the ballpark, man. That's actually perfect. But we didn't sit here saying that we would, you know, that we wouldn't need to overclock these, you know. Let me just try something. What is this gonna do if we just did that? Double it. If we doubled the thrust on our whiplashes, 0.24. That's only 1/3 of the thrust away once it's going at about 450. But the real question is, can these whiplashes accelerate us to that speed? I'm wondering if they could even get us to the right altitude, Tessa. We need to shoot.
Discovery.
So the real one shot for 20,000 feet. And they had to do a dive at 20,000 feet to get the turbo ramjets to turn on. What's our 20,000 feet? 7,500 meters, which actually is about 20. It's more than 20,000 feet, but it's close. Like, that's close enough. So we're going to need to get up to like 8,000 and then do the dive to get the ramjets to turn on. Do we really have that type of performance with the whiplash up there? Hey, oh no, 37-month resub. Thanks, man. How you doing, buddy? More jets. Some guy just hold off on that. That's a bad idea. They won't generate. They're not. They don't have to, Tessa. This is designed to get us up off the ground, and the real one called for a turbofan ramjet engine. That's basically what we got here. This is a turbofan ramjet. We couple this with some pre-coolers. We should be good, but. That should do it. Hyperboles wouldn't. I'm not sure what the scale of atmospheric fall off is, Hellfish. I've guessed at it like that 30,000 feet is like double, but in this case, these things need 7,000. They need to be above 7,000 going 350, something like that. If we can get our speed at 7,000, like, and this is why I'm thinking like the Goliaths like might not be the worst idea. Or we could overclock whiplashes. I mean, the Goliath working with the whiplash, if we can figure out a way, like this is just putting it here so I can see the numbers. If we can figure out a way to get these two to jive together, and basically having the bypass, right, with the whiplash, right, then we might be in business here. It's either that or overclocking the whiplashes to get them to work more like the Goliath, but they can be at any altitude, but you need the whips to be going 4,000 meters a second to start in a ram, or 400 meters a second to start in a ramjet mode. Basically, those Goliaths are there, Tessa, to get us up to the right altitude. I would shut the bypass off when we went to do the dive, and we'd work solely off of whiplashes. As long as we could get the whiplashes to the point where we get to 400 and they go into ramjet mode, yeah, the Goliaths don't need to be there. Those are just there to get us the thrust to take off, to get up in the air. Like, once again, I'm just experimenting with different ideas. Center of mass is still not bad. It's still pretty good. And then, yeah, I mean, Tessa, you said do this, but just... Is this solid enough that if you covered it in lift surfaces to... That if you covered it in lift surfaces to get up there? Yeah. That's why 0.13 TWR might have the performance to get us there, dude, but... The other way that we could really figure this out is just have the whiplashes going, right? And then, you know, obviously don't have any fuel in these tanks. Do a flight test without the shuttle engines just to see if this thing can get up to turbo ramjet. If we do it with no fuel in the tanks and it gets up to turbo ramjet real easily, then we're fine. We'll know it'll... I mean, that's not... It's a step in the right direction. It doesn't conclusively prove it, but... Yeah, we're going to have to do flight testing with this thing. A lot of it. Well, let's find out. Throw a load of Fat 455 and shuttle deltas on and see what happens. I don't want to do that, Tessa. I don't think that's a good idea. The reason why is that, you know, you build it out and you build out your wings. I start working on the wings, and then we get it, you know, say we get it to work. Then I have to go remake the wings later. I don't want to do that. It'll fly completely differently. You're putting it into a test regime that's going to be nothing like the actual thing. That's why I wanted to build the shell out first. You guys, I mean, you guys want to get into prop, which is fine, but there are other things that we need to flesh out before we figure this out. I just wanted to see some numbers here. This works. That's enough. Our burn time is 1,700 seconds, though. I actually think that's too much fuel, to be honest with you. I think that is too much. That's too much. The case here. Let me take a look at something. 1,700 seconds of fuel with all of these engines going, with 10 turbo ramjet propulsion systems that we're messing around with. How much does the K90 have in total? I mean, granted, that fuel's going to get sucked up real quick once they go into ramjet mode. So, let's just take a look. That's 4,500. 4,500 is enough to fly all the way around Kerbin and back. Interesting. It's... Why is there no Delta V listed for stage 0? I have the tanks locked out, chillin'. The tanks are locked out, so there's no fuel feeding the engines. That's why there's no Delta V indicator here. If I took one of the tanks and opened it, it would give me a number. It gives you a total number, but you get the idea. Wait a minute. Why is... Oh, 7155, okay. Yeah, that's true. Yeah, I mean, it should be enough. Okay. Okay. I think we're good enough to go forward with starting to build stuff out. This is a good enough indicator of what I'm looking for. What I would really want to test later, and this is after we build out the shell, is what... I mean, that's not bad. This isn't bad the way that is. 0.12 TWR is a little bit on the low side. She's going to lumber a little bit on ascent. And I'm not 100% sure that that's going to be enough. .07 TWR. I don't think that's going to be enough to keep us afloat. That's what I'm worried about. That's where the high bypasses will come into play. See, the Whiplash is not a bypass. It's not a bypass. The Ramjet is the bypass. So having the Goliaths incorporated into our propulsion design is not the worst idea. What was the TWR in rocket mode? Oh, I'm not 100% sure. Put that up here. Close out the liquid fuel tanks. Give me 1 second. Just needed to restart the tunage. Now it's only 2,400. .28. It's the mass of those for sure. Oh. Okay. Hang on, I'm just trying to figure out some fuel equations here. Well, not equations, I'm just looking at what the computer is telling me. Huh. Why is it reading 0 all of this? Oh, hold on. I missed one. No air intakes? Oh. Yeah. Okay. Where is it?
Discovery, go at throttle up.
Hey, animal, 55 months. Addly diddly. Addly diddly, neighbor. I don't know, Tessa. I don't know. Thanks, Master. Oh, you broke it. Oh, that was my most favorite piece. Oh my god. Oh, you idiot, Tessa, you glued it on upside down. God meant to do it that way, we'd all be pissing in our faces. It looks fine to me. Still good, man. Still funny. A little bit of debug here. Works now. Altitude. Yeah. Oh, vent down on the main stage. On the NASA space flight up there. Yeah, that's a big vent down. I would say the tests are done for the day there. Nice, Bucket. Yeah, you did call it. I think this more or less is the combination that we need, guys. More or less. Wait, 862. Hold on. Where's it picking up fuel? Oh, there we go. Yeah, I think I just had it set to vacuum. That's where we're getting confused. .10 TWR though. Do you need intakes? Hold on. Does that make the difference? No. Yeah, you don't need intakes, but it was good to have. See, 0.10 TWR. She's heavy, man. I don't know. 0.3 TWR boost. The engine plate is what's causing that to drop. What? No, I added fuel tanks bucket. Yeah, I'm not sure if that's going to be enough. Okay. Alright, we need a plane. I gotta check something. Let's get the XB-70 out. I don't know what that is, John. Sorry, buddy. funny thing is that that kind of is exactly what the engines look like. Yeah, they're turbo ramjets. They're intercooled turbo ramjets, which is, like I said, that's pretty much what it looks like. Gotta find it. Yeah, see? I mean, there's a huge bypass going through it. See? It's a bypass turbofan, high bypass turbofan ramjet. I'm looking around a little bit more. Yeah, here, let's take a look. Yeah, that's... So they have their turbojet combustion chamber up front. Free turbine fan assembly, ramjet turbojet turbine compressor. It's like a backwards turbofan. Whoa, that's weird. Now that I'm actually looking at this. Huh. It's backwards, Tessa. Yeah, it's backwards. That has the bypass behind the turbojet, which is strange to begin with. That's weird. So like, okay, so let me explain a little bit on airplane propulsion here, if I'm understanding this right. Let me get the flag out there. So, okay, guys, the Goliath in game is a turbofan engine, specifically a high bypass turbofan. Now, what's a high bypass turbofan? High bypass turbofan. Boop. Just look at a picture of one. This is what the Goliath's supposed to be. Most modern airliners nowadays have something like this. What does a bypass turbofan do? Well, it's a jet engine that's spinning a ducted fan. Hence, turbojet fan, turbofan. Pretty straightforward stuff. You have the major fan here, right? The big fan. That does like 80% of the thrust. Now, the reason why it's called a bypass is because basically one of the axial compressors, right, on this jet engine is bypassing the entire jet engine. Hence, high bypass. There's high bypass turbofans, there's low bypass turbofans. So just in case anybody's wondering, how the heck does a jet engine work? Okay, you have a jet engine consists of three critical components. You have your compressor, compresses air. You have your combustor, which combusts air, and then you have your turbines. Your turbines spin the compressors. Okay, so when you turn a jet engine on, you start to spin it, the compressor sucks in the air, it compresses it, it forces it into a combustor, and the combustor basically works on the same principle as like a grill. Like if you have a propane grill, like you ignite it and the explosion is self-sustaining, so to speak. It just depends on how much fuel you deliver. You can get a bigger fire if you turn the propane all the way on a grill, but all you got to do is light it once, right? So you have an igniter in here, right? And what happens is the bypass air gets forced through tiny little holes into the combustor, and it goes from extremely high pressure in the compressors here to lower, and that basically spreads the air out, and they spray fuel into it and light it on fire. The resulting explosion goes out the back, and the hot gases basically push on the turbine wheel. That's like the equivalent of if you have a fan, like a pinwheel, and you blow into it, it'll spin the wheel. It spins the turbine blades, and those turbine blades end up spinning the compressor blades more. So it really depends on how much fuel you deliver, and that's why the throttle on a jet, that's what the throttle on a jet engine does. It's metering your fuel flow, because the more fuel you flow, the faster, the bigger the explosion, the faster the turbines spin. Throttling up a jet engine. Pretty straightforward stuff. Now, a bypass turbofan, like I said, is a little bit more complicated than that. There's 2 axles here. The turbine, the N2, right here, is actually, the explosion is gigantic inside of here, but it's not enough to just spin the turbine, right? With a turbojet, obviously, you get thrust coming out the back. The hot gases go past the turbine and they shoot out the back and you can make thrust. That's how old fighter jets work, right? Now, with modern stuff, instead of taking that thrust and just shooting it out the back and using it to fly, right? They have another set of turbines here, which is called the N2. This is the N2 axle. There's the turbojet axle is hollow, and a solid axle, the N1 axle is hollow, and the N2 axle goes through it. So all that gas that gets pushed out the back ends up spinning these turbine blades. These turbine blades end up spinning additional compressors at the front, but the first compression blade is a bypass. It goes past the entire jet engine. This design is basically using a jet engine to spin a fan, and that fan is what makes thrust, hence turbofan, right? So the thing about bypass turbofans is that they are absurdly fuel efficient. They're very, very fuel efficient. They're not really good at going fast, though, hence why most passenger planes have them. If you want to make something go faster than the speed of sound, for instance, you're going to need to come up with a more elaborate solution than this. Now, don't get me wrong, intake geometry on modern jets can get around that. We have turbofans inside of like F-15s, and they can, or an F-22, and they can go well past the sound barrier. But that's not necessarily because of the engine. Now, the point that I'm trying to illustrate is that the bypass fan and the ducting for said fan is usually up at the front in kind of a typical turbofan design. You have your bypass up here. On this design here, you have your turbojet first and your bypass fan second. The bypass fan is actually on the back, that's a little weird. But it's, see, air turbo exchanger manifold, LH2 Rankine cycle, free turbine fan assembly, ramjet fuel injector. The reason why they did that is because this is a ramjet. It's a high bypass turbo ramjet. They basically took this and put this part back here. So it's a turbojet with a fan attached to the back instead of going through and going out the front. My guess is the reason why they needed to do that, once again, is for the LH2 Rankine cycle and for the ramjet. May I offer a better image? Yeah, sure, I guess. Yeah, look at that thing. Yeah. So, with a high bypass turbofan, they're super efficient, and the fan is generating most of the thrust, like 80% of the thrust. There's still some jet exhaust that comes out the back, but the fan actually does the majority of the movement, or of the movement of like an airplane, for instance. This is really sweet, Crash, by the way, with temperatures. Nice. Now, yeah, there's your combustor right there. See, if you look at it from the side, the air is going through a funnel. It goes basically into a funnel, and these blades actually force it into that funnel, and then they force it through a little nozzle right there. Yeah, high pressure compressor exit right there. It basically goes from really, really high compression into the combustor, and it spreads out into the combustor. You spray fuel into that, it atomizes with it instantly, and similar to what a carburetor does. Actually, yeah, it's quite similar. It just does it with fans instead of pistons going up and down. But anyway, yeah, this is great, Crash. It's really good. Or, if you like Star Wars, pod racer engine. The thing about those pod racer engines, though, is that bypass turbofans don't like breaking the sound barrier. There's a lot of reasons for that. The big reason is that, well, with this design, the air is getting shot out the back at subsonic speed. Okay? Think about the airspeed coming out the back. And think about if you're going the speed of sound. If the airspeed going into it is faster than going out the back, your engine's not doing anything. It's a big speed break at that point. The solution that, fighter jet engineers came up with to get around this problem is to basically create drag inside of the intake. Creating drag and impingements inside of the intake will actually slow the air down to subsonic speeds, but you still need subsonic laminar flow for this thing to work correctly. Basically, you need clean air. The problem with slowing down air is that it usually makes drag. So think about that for a second. Think about like the next time you see an F-22 flying around. F-22s can break the sound barrier with no afterburner. Think about the intake geometry needed to feed subsonic laminar flow into a high bypass turbofan going Mach 2. The intake air is going twice the speed of sound. And the exit, stuff coming out the back, needs to not be going as fast as what's coming in. Weird, right? I mean, that's the plain Jane way. The fan doesn't like supersonic speeds, but yeah, because of compressor stall, certainly don't want your blades to create shocks inside your engine. Big upfront blades would be like a helicopter trying to go supersonic. Yep. You're right, that's more it, Rocket Guy, but that's the plain Jane way of saying it. Basically, the air coming in here shouldn't be going faster than here, or else these don't do anything. They slow you down. That's why actually, Rocket, a good example would be like a propeller-driven aircraft. Prop-driven aircraft don't like going past even anywhere near the sound barrier, right? This is why like a P-51 could only break the sound barrier in a dive or something, or like a Spitfire or a Zero or whatever. And even then you're running into other problems once you get into transonic with a plane that's not designed to do that, but that's another story. Yeah, the thunder screech, yeah, they figured out why you don't want to do that, Nils, but yeah. Yep. So, it's very interesting in Star Raker's design because they have the jet first and the bypass second. And the bypass is actually going into a ramjet, which is very strange. Rocket, looking at this, dude, the hydrogen is exchanging. The hydrogen is exchanging the bypass here. See, they have regeneratively cooled chambers. Now, my question here, now I'm wondering how so I see how the intake works, jet intake. There's a turbojet shutoff valve, right? But now air turbo exchanger manifold, free turbine fan assembly. The air seems to be, at higher speeds, it seems to go through the bypass like on a SR-71. But how are they going to get the bypass past the blades? Someone in chat was trying to tell me about this the other day, and I was working on something else, so I couldn't picture it in my head. I need to read a little bit. And understanding this is really important because that'll help us make it in Kerbal better. Well, not make it in Kerbal better, make it work. Well, Rocket Guy, it looks like so I understand this part, the turbojet. And it looks like they have their bypass fan on the back of the turbojet here. And then there's a turbojet shutoff, so they can block the intake on the turbojet at high speed. Now, what I'm wondering is that their bypass turns into the ramjet. It seems kind of like an SR-71 here, But that means they're getting supersonic air moved in through the air exchanger manifold, through the bypass here. It's through the bypass, and if it's through the bypass, what the hell is the fan doing? How can they get it bypassing the air into the impingement where the ramjet injector is going to... I'm missing something. I gotta read. Give me 1 second. The multi-cycle air breathing system engine, figure 7, is derived from the General Electric CJ805. All right, let's let me just look at that. Okay. Oh, that's where I know the CJ805. Dude, that's a J79 with no afterburner. CJ805s are on the Convair 990. That's a J70. That's a civilian version of a J79. That's an F4 Phantom engine. This thing was going to have 10 of those. Whoa. The difference between a CJ805 and a J79 is the reheat, the afterburner. Whoa. The CJ805-3 was a turbojet and powered the 880 airliner, while the CJ805-23 military designation TF-35 turbofan, a turbofan derivative, powered the 990. Oh, they made a turbofan version of it. That's the 805-23. That's the version that I think they're... Wait a minute. Okay, alright, I need to read more. CJ805-23. The bypass is in the... It's in the back. Chief continued the stuff they got from Hoagie. Hoagie, thanks, man. The high bypass turbofan variant of the 805 has the bypass fans out back. Suddenly this makes a little bit more sense now. But why? Dude, I don't have the answer to that question, man. I honestly don't. I don't have the answer to that. I'll keep that picture for later. Yeah, look, it's got the bypass in the back. I was looking at look at that. Look at that. It's backwards. Yeah, aft turbofan. I mean, this design would be simpler than a modern one because you wouldn't need the axle going through. If you were going to retrofit a turbojet engine, right? If you were going to retrofit a turbojet engine to have a fan on it, that's what I would do it that way. That way you don't need to redesign the entire jet engine. It's a good stopgap, but that's very... I didn't know that. I did not know this. The space in the front and back is where you have the ramp intake. Well, the ramp intake is before the entire engine, dude. See? They have variable geometry. And every time it's going into this bypass over here. So, okay, that explains that part. The Pratt & Whitney SWAT 201. Now I gotta read about that. P&W SWAT 201. Nope. Okay. Supersonic wraparound turbofan. You found something. Well, aft turbofans are easier to design and manufacture in comparison to forward fan designs, but at the expense of all else. Yeah. If you were going to retrofit something, yeah. All right, O-Force, what do we got? Well, that's thrust augmentation. I'm not 100% sure that that's what we're looking for. Past page 20. Damien's, what's that? Hey, I found a cool Kerbal keyboard keycap you should check out. Let me see. Nice. That's funny, man. From Wikipedia, the problems Rolls-Royce and Pratt & Whitney had addressed with the two-spool system had been solved on the J79 with variable stators. So in relative terms, the single compressor rotational speed was much faster than the low-pressure stage of these other engines. That meant that it was not suitable for direct connection to a fan shape. Instead, GE solved this problem with the addition of a completely separate fan system at the rear of the engine powered by a new turbine stage. Two-spool system had been solved on the J79 with variable stators. The single compressor rotational speed was much faster than the low pressure stage of the other engines. Okay, I get it. So okay, that's the wraparound part. The wraparound part is this piece, right? Air turbo rocket. So let's go Aerojet air turbo rocket engine. Oh. Yeah, the wraparound seems to be, somebody said it, that seems to be what the SR-71 is doing. There's bypasses in there. So you can bypass the jet engine entirely. I interest you in something super sweet with 3 question marks this time. Yeah, sure. It's not a scramjet, I don't think. This is afterburning fuel burners. The real life version uses SRB. Oh. You have a naturally aspirated oxidizer on a hybrid SRB. That's... okay. Scramjet has no moving parts. No, this is... oh, man. This is... you know, I've been saying that Star Raker has, you know... it has 10 SR-71 engines in it. No, it's... no. Nope. It's more complicated than that. Yep. Minute 5 headphone user warning. Oh, nice. Oh, this is Agent JZ. Yeah, he's running a J79. Nice. Yeah, we've seen that video. Dude, that's so cool. Neat. So the wraparound part is this. That part is kind of like an SR-71. But what's still crazy to me is, I want to stay focused, Tessa. I want to stay focused. Click on Chief's link. It's really, really cool. Go 5 minutes in. It shows the high-def video of a J79 just yeeting pretty hard. No, it doesn't have a scramjet. I know it doesn't. I said it didn't. Star Raker engines are just ramjet. The intake decelerates the air like the J58 does. It's not necessarily an aero spike, Hellfish. They instead of a variable geometry thrust vector on their design, it's a static nozzle. So air turbo rocket, yeah. Marquardt variable plug nozzle, ramjet engine technology, and Rocketdyne tubular cooled high pressure rocket engine tech. The whole thing would have been film cooled. Not only would they be slowing down the intake air, but it's cooling it on the... this is the whole engine is regeneratively cooled. This is basically like a high bypass turbofan sitting inside of a rocket's combustion chamber with the top of the combustion chamber open for intake air to come in. Okay, I get it. I see what's going on here. The only thing that I'm kind of about is the Rankine cycle here. I got it. I see what it does. And it's a variable geometry. It's variable geometry. Instead of a variable geometry impingement like that, it goes through a convergent divergent exhaust. See, variable, that one's variable. Oh man, this thing. That, okay. It's an SR-71 Sabre engine. Yeah, it's almost, dude, yeah, guys, it's almost, this is almost a Sabre engine, dude. It uses geometry in the shockwave to decelerate the air to subsonic, but that makes the air pile up, compressing and heating it. This is why the J58's limit was melting the intake. Yeah, okay. Problem wasn't the point. It was inside where the air decelerates. This solved that problem by making the entire inner surface regeneratively cooled. Okay. Let me read this real quick. I gotta remember. Interesting. Okay. So, yeah. Dude, this is wild, man. It's a pre-cooler. Yeah, This part right here. That's is it the air turbo exchanger manifold? That's not a blade per se. It's literally a spinning intercooler that has hydrogen flowing through it. That's acting as the it's the rotary regenerator from Chrysler's turbine car, Tessa. It's the rotary regenerator. That's exactly what it's doing. The rotary regenerator uses Rankine in Chrysler's turbine car. Yeah, the whole nozzle is regeneratively cooled on top of that. Let me read. An LH2 regenerative Rankine air turbo exchanger cycle. It's an air hydrogen intercooler, like a turbo yeah, and it's preheating the hydrogen. Yeah, that's exactly what the Chrysler turbine car does. It's an intercooler. That's their pre-cooler. That's what they're using as a pre-cooler. Dude, this is not that far off from Sabre, from Reaction Engine's Sabre. But the Sabre engine uses a closed-loop helium pre-cooler and not LH2, interestingly enough. The engine components include a rotary vane assembly to close off the compressor turbine assembly at higher Mach numbers. Okay, got that part. LH2 fuel permits the use of a Rankine cycle air turbo exchanger cycle to provide power for the bypass fan. This allows the elimination of approximately 1/2 of the turbofan compressor stages normally needed for fan drive. Heating of the LH2 on the outer walls and nozzle plug of the tubular. This allows elimination of approximately 1/2 of the turbofan compressor stages normally needed for fan drive. Heating of the LH2 in the outer walls and nozzle plug of tubular construction, in addition to providing fan-driven power, permits stoichiometric combustion. Yeah, Rocket, it's a jet. It's a jet that's using the hot intake air in like an expander cycle. That's wild, man. Dude, that's actually... You know what, man? Like, the past couple of days I've been looking at this and going, nope. That would have been hard to do. It would have been tough combining all this together, but that's not nearly as complicated as I was kind of thinking. I mean, don't get me wrong. That's difficult to make. But I'll tell you right now, that's difficult to make. But that's actually pretty simple principles of operation. Just like an RL-10 is complicated to make, but its operation is literally... The expander cycle is one of the simplest forms of combustion cycles with rocket engines, you know? Sabre cools the air. This doesn't cool the air. It does, though, but instead just tanks the heat and pumps even more energy into it. One of the amazing things about the J58 is that because the energy of the incoming supersonic air is actually... The energy from the incoming supersonic air is actually preserved and passed into the exhaust. It was much more fuel efficient in afterburner mode than first expected because they accidentally made a ramjet. I mean, wasn't that the whole purpose? I can see this engine being what ends up being used on newer supersonic airliners. When they start making RL-10s with channel wall chambers and nozzles, they'll be a lot simpler to mass produce if they ever do that. 3D printing the cooling channels on an RL-10 Cynerd could be useful. But one does not simply 3D print RL-10's cooling channels. That's, yeah. That's actually pretty cool, man. Now, my question here is for the 805, the CJ805-23. That fan is free spinning of the turbojet, just like it would be with a modern turbofan design, right? It's free spinning. It's not geared to the turbine at all. That actually gets... The funny thing is that that's actually super beneficial for doing this. Because at low speed, your bypasses at low speed, right? These fans work as the bypass at low speed, but at high speed they work like a ramjet, and they exchange the heat on top of that. I don't think that it drives a turbine though. I think this is relying on variable intake air geometry and the turbine exchanger to not have this part. You don't have this part. You have everything else, if I'm looking at this right. They weren't expecting the ramjet mode operation. It actually surprised them. The bypass was originally intended as temperature control via expansion cooling and reducing the complexity by not needing to make a multi-stage compressor with nested shafts. Multi-mode engine design is super complicated because all 4 of the components can receive fuel at any time combination. Turbojet core, air turbo exchanger, ramjet, and turbofan. That would have been one heck of a fuel manifold, and there's 10 of them, Rocket Guy. Yeah. Look at Starbase. SpaceX is doing a mass vent from the new engine section vents.
Discovery, go at throttle up.
Oh, we've been using... Here. There we go. I've had it up. Hey, Xeon, what's up, man? Gotta go back a minute or so. Oh yeah, I think I see it. Yeah, cool. I think that's what you wanted to see. Fun rabbit hole dive. Back to work for you. It's designed to go from subsonic to Mach 6 flight regimes. Now, I'm wondering if the Star Raker engine has this. I'm wondering if it has that component. I don't think so. I don't think it does. Nah, it's way bigger. Oh, I see it, Thomas. I see it. Whoa! Oh, cool. Ah, I get you. Oh yeah, I see the vents. So the inner rings of engines vent down and the outer rings vent radial. That's cool, man. That's really cool. Guys, and once again, the reason why I did this deep dive into this is because I need to understand what this is doing to see if there's any analog in Kerbal. I think I got it. Hey, Dwarf Man. It's that time again. Yeah, Synerd, that's exactly what I did. I snooped around a little bit. GT should be good, man. The GT soundtrack is good. For now. I might go back to Robert Parker. Interesting to note that the fan system is both part of a lower pressure turbine system and the compressor section also has its own turbines. Both run on separate combustion chambers, it seems, and also combined combustion chambers. So, Rocket Guy, we have... Alright, I'm going to try to plain English this for everybody else. It has this, right? But the turbines on the back here are... So you have this, you have this, but your turbine fan is back here, right? And then you have this thing. But with this thing, you don't have this part. With this thing, this part is also the turbines on the engine. Right? Is that what we're saying? This part This part right here on this thing is right there, and the turbines are shared. Give me 1 second, guys. What's up, Bree? Yeah. Okay. Yeah. Yeah, those aren't bad. Patio furniture, chat. You can always... Yeah, we could paint them. Yeah, I mean, they look fine to me. Just get the truck. You know how to do this. Okay, ask if you can pick them up later. Love you too. Bye. We're gonna have enough patio furniture to fill the damn backyard. I see it. I see the venting, Thomas. It looks like they tested it again. Seems so. It has a ramjet on the back, a free fan turbine section, assuming that to mean that the fans are directly part of the turbine blades for the turbojet part. So it's kind of wild. And with that, it has the expander cycle wrapped into it as well. Yeah. Yeah, Rocket Guy. So the turbojet, when it's turbojetting, it works like this, right? Tater, you were talking about it. You said it while I was answering the phone. There's a turbojet here, right? And then this part right here, the turbines for the wraparound air rocket engine utilize the turbines on the turbojet, which is strange. They close the compressor inlet on the turbojet, but they use the turbines. Holy balls, this thing is complicated. Whoa. Well, Tater, we're looking at Star Raker's engines, dude, and it's a combination of things. You're right about the back turbine. Dude, you know what's weird? I'm learning new stuff all the time. I did not know that an 805-23 has an aft turbofan. The bypass is in the back, which is... Alright. I didn't know that. I didn't know that. They were going to use this as their turbojet, right? And then the freewheeling bypass fan, which is also the turbine for the bypass, right? That's in the back. But what they wanted to do was have an intercooler, basically a rotating intercooler on one of the fan blades. And that rotating intercooler would have basically preheated the hydrogen for the jet. Dude, this is complicated, man. Wow. I knew that this engine was complicated. And then on the back of the engine, they have this. But, so this is the Aerojet air turbo rocket engine. It's half rocket, half jet, right? Here, actually, that one. Let's go. Air turbo rocket. This guy, right here. What the frick? And their air turbo ramjet engine design on Star Raker. I don't know where, I'm failing to understand where this turbine element is. I teach aeronautics and airframe and power plant mechanics for a Part 147 program at a local college. Blows my mind every day. I learn something new. Dude, I'm failing to understand for the air turbo ramjet, dude, where the heck this part is. Like, so they have their variable plug nozzle. I get that part. I need to see a bigger picture of this motor. Hold on. I think Rocket Guy was trying to tell me. I mean, he's working, so you know, Rocket Guy, do your thing. Don't worry about it. So you have a turbojet at the front. That's a CJ805. right? Backwards turbofan. Okay, I get that. I understand that part.
Discovery, go at throttle up.
And then you have your air turbine exchanger. So there's basically a rotating, there's a turbine here that's attached. I am stupid. I'm stupid. Okay. Alright. Alright. I think I got it. Chat, if you understand this, you be the judge. So you have your engine right here. Out at the front, you have your turbojet, right? This is the 805. Right? And then you have your turbine blades here, and you have your axial compressors right here, right? Okay. Right? That's the CJ805. Then you have your bypass fans right here. There's 3 of them. What I was getting confused by is that when this thing is in turbojet mode, or turbofan mode, the jet engine is blowing on these fans right here. Now these fans are those. Not those. Hold on. It's those 2 in the back right there on the 805, right? Those guys. But see, I'm thinking of the fan as just a fan. On the 805, it's a turbine and a fan. Because the jet engine is blowing on the fan. The fan is the turbine. It's a turbine down low and fan up at the bypass point, right? So this part right here, those are turbines, right? And then you have the back part of the nozzle right here, or the back part of the engine, which is the air-breathing rocket, right? Right, and you have your nozzle, right? Now, we were looking at air turbo rockets, right? Or air turbo ramjets, right? That has all the turbine machinery here, and you have bypass, you have your intake fan, your compressor fans up here. That's connected to machinery in these diagrams with a jet engine here. You don't need to do that. You don't need to do that with this type of design, because your turbine machinery and gearbox are already built into this design. They're already built in on the 805. The turbine and the fan is the same thing. So they have basically a conic intake right here, and the intakes have hinges that can open and close. Well, not that way. This thing can basically go inwards, right? So you can open the intake and close it, right? When this is in the closed position, the jet engine, when you're going fast, it isn't getting any air. It's shut off. And that wraparound intake basically opens up a vent that goes in here, like that. And that spins the blades. That spins this. And that also cools the air going backwards, and then you have a variable plug. I don't know why I can't draw that, but whatever. So this thing right there opens and allows intake air to go through and spin the turbines, which spins this, which cools it. Like I said, easier to manufacture for lack of all else. Holy balls, dude. So right here, the air can go in like that. And then right here on the outsides, you have another ramped intake. These things can move. And that slows down the air and basically gets it to compress inside of here. And so some of it goes through the blades, right? And some of it pinwheels that turbine right there. So at high enough speeds, the intake air will just spin this thing. And then you have a fuel delivery manifold right here and here, and then boom. You have a ramjet that's being shot out of a convergent divergent nozzle. God dang, that's really smart, actually. It's a turbo supercharger for a turbojet. Yeah. It's an intercooled turbo ramjet. That's freaking, dude. That's, you know what, man? That's really smart. That is really smart for what it is. Considering somebody thought this up with no computers or anything, that's... And remember, the airflow won't necessarily ever get that fast, so to speak, because of this. Because of this is then inside the variable ramp intake. You know what, Rocket? I know this is a logic fallacy here. That's not actually as complicated as I thought. That's actually really smart. You're taking the best parts of a turbo ramjet and you're combining it with the 205 aft turbine fans, and then the Rankine cycle would have been the hard part. That would have been the hard part to make. But this part actually not. I mean, don't get me wrong. It's all rocket science, right? Like, obviously, it's difficult, right? I get it. I see what this is doing. I see it. And then they have the variable plug nozzle. Basically, you could... I'm not going to say that you can throttle the ramjet, but I'm pretty sure that impingement... You can set the variation of impingement and throttle it that way. Why in the balls don't we make something like this? I know the reasons. But I mean, the closest thing is the SR-71, right? Yeah, there you go, Hellfish, nice. Okay, phone sister, got it. Yeah, turbojet turbine compressor drive. Yeah, you're driving the compressors, but there's a bypass here that lets intake air go in to the turbines. It's somewhere in this design. I think it's right here. Holy cow, that's wild. Zizep, when am I designing this? I need to come up with a power plant because this is the engine for that thing, and that's what I'm building. And in order to understand what this thing's supposed to do, I needed to figure out how the engine worked. Yeah, that's for Star Raker. Star Raker is a horizontal takeoff, horizontal landing SSTO. It's freaking huge. Yeah. See this? That doesn't exist in KSP. We're going to have to make it. We can combine a couple engines together to make it, but I want to say the EGT was in excess of 1,000 centigrade. I mean, Tater, yeah, you seeing this thing? A bypass duct into your turbine exhaust to spin a Rankine cycle heat exchanger to compress air for a ramjet injector, for a ramjet engine, with a variable nozzle convergent divergent plug design for throttleability. They never actually built it, Buck. It's made out of, believe it or not, it's made out of 3 or 4 different motors. I mean, they said that, and they say this in the PDF. So something I didn't know. This was the point where I was like, okay, or at least the point we started going on the right track. What can you look at that thing? What can you tell me about this engine? They said they were going to use a CJ805. The CJ805, believe it or not, has the bypass fan in the back. See that? The bypass fan's in the back. Look, the jet intake is right there, and then there's a bypass intake. because the turbofan is out back. It's not out in the front like a regular like kind of garden variety turbofan design. I didn't know that. That makes this a lot easier to understand. Because the turbofans are back here on the 805, right? And if you look at this PDF of an air turbo ramjet engine, right? They took the front of this thing. They took the front of this, the air turbo ramjet, and attached it to the back of an 805. The freewheeling turbine fan bypass blades on this are the front of the turbo ramjet. That's those blades there. They act as a turbine when the 205 is, or the 805-23 is on. These things act like a bypass turbofan. When you start going faster, the air turbo ram, and you get into turbocharged ramjet engine, right? These things act as a compressor instead of a bypass. They basically put a ramjet engine on the back of an 805-23. They attached the ramjet engine to the back of this thing. Just stop now. You are gluing words to make word confetti. Inside of a variable ramp intake, 10 of them. Yeah, I mean, Crash, you're saying word confetti, yet you know, there's other people in chat saying that it's not that. But, you know, whatever. I'll stop talking. I'll just build it in Kerbal. Whatever. Knowing what we know about that now, how are we going to make this? How are we going to make it work? Okay, yeah, I don't think I got the Kappa. Yeah, alright. I was gonna say, dude, I think I got a good grasp on this, man. Piss off. What about the notifications you got? Hey, Zizep, thanks for the resub. 69 months. Nice. The biggest problem with system was the heat load, which their solution was LH2 regen. That's the only really part of that engine that didn't exist, the Rankine cycle turbine exchanger, which is interesting. It's basically an intercooler that spins on a turbine blade, which is... I mean, I'm not saying that couldn't be done. I'm saying that would be a little complicated. So we do have the option to close the intake on the fan, right? But we're going to need the ramjet to work correctly. Didn't the image showing them bypassing the compressors for the turbojets had said high speed the compressors would no longer be effective in impinge airflow? Instead, the bypass for the part of the ramjet spike... Instead, the bypass for part of the ramjet spike inlet to compress the air to high temperatures and get it to transonic regime so it could be combusted. Yeah, they bypass the compressors and then somehow it pinwheels. I don't even think it goes into the turbines here. It might just... The intake air might... free turning fan, turbine fan assembly. I think they just act as compressors and they spray it through. They spray the fuel in the oxidizer in here. It compresses it and then they spray into it. I thought there would be like some kind of vent here to get some intake air to go over the turbines to spin these. But if they have a turbine up in the front and then a compressor behind it, or vice versa, and then they spray hydrogen over it, and then that atomized hydrogen goes through a ramjet injector assembly. Yeah. That's wild, dude. Rocket Guy, my real question is, how do they keep this turbine spinning? Is that... The turbine is out in front and it's spinning a compressor wheel behind it, right? Am I looking at this correctly? The fan is the turbine, just extends outside of the turbine assembly area. So the bypass, the two-stage bypass in turbojet mode is your bypass fan, but in ramjet mode, they're your turbine and your compressor. Well, any fan will spin with oncoming airflow. The turbojet becomes a gas generator when its air intake is closed off. Probably has a small supply of LOX as well as LH2 to keep the part spinning. I don't think that's right, Steiner. I'm not sure, though. The compressors on the turbojet have a separate turbine assembly, it shows. Yeah, okay. Yeah, that's the one part where I'm getting hung up on. But I think I understand it enough to get it. So let's mess with this. So what would be cool is if we put this up at the front to make it look like the 805, right? And then if we took this, the whiplash piece, right? And we gizmoed that into position. And we took it so the thrust limiter doesn't change right there. Yes, Fleiken. Yes, it would. It just pinwheels. When it's at lower speeds, they use the turbine exhaust on the inner portion. Yeah, so yeah, it just pinwheels. There's no bypass event. That's too complicated. So that it's just that blade is spinning and it's being used to cool everything. Got it. And that's what makes the ramjet. And then with a variable ramp, they slow it down to subsonic speed so it can pinwheel correctly. It cools the air, that it exchanges heat with it, right? The Rankine cycle, and then the ramjet does its thing out back. I get it. Can you combine engines in KSP? They seem to have no problem doing it in real life, Marco. I think we I don't see why we can't. They have no problem combining 3 or 4 different engine concepts here. I don't see why we wouldn't be able to do that. They clipped parts before it was a thing. They said more engines. They did say more engines. I mean, what are they doing but that? Like, they seriously, they attached a air-breathing turbo rocket to the back of a turbofan engine, and then added a pre-cooler. They made the bypass blades a pre-cooler. We have a pre-cooler here. We have a turbo ramjet, And we have a high bypass turbofan. I don't see why we can't do the same thing. And as long as the thrust transforms are coplanar with each other, meaning if I disable the thrust limiter here and the center of thrust doesn't change, it'll do exactly what we need to do. We should be able to shut the bypass fan off. Why bother with engines when we have UAPs? Well, I made a UAP in this. We made a flying barrel. Oh, it goes fast, don't worry. Okay, I think I understand this enough. Now, how do we... I mean, that's good right there, but... I'm thinking, how do we make the FADEC work for this thing? Oh, Steinert, I don't... I got an idea. Don't you worry. Alright, before we get into this, before we do that... I need to do, the first test that we need to do here is this. Okay, so this is an open fairing, right? And I need... we need to put this in here. Let's make sure that the thrust transform is aligned. It is. Okay, now we need something to make it look like we're... so be able to visualize the thrust. So what we'll do is this. Like this. Go here like that. Yeah, I'll check that out later, Aqualex. I didn't know that. It's very interesting. I need this. What did you take on all this UAP stuff? I don't know. Monkey, I don't really deal with theoreticals, dude. I deal with we mostly deal with like laws of physics on this stream, man. So I don't know, dude. I don't have an answer for you. my inclination is to just shut up and let it ride and see what happens. If they're, I will say this though, if they are real, can we please, for the love of God, please try to, like, can we get access to that so we can, you know, get back to the moon easier? That would be really useful. I think that would be useful for us. You know what I mean? The heck is this thing? I need to make sure that none of the thrust transforms are blocked with what we're doing, guys. Just bear with me. So I'm going to make something that will visualize us moving this thing. You'll see. I need to, because if we just put it on the test stand, we fire the engine, we're not going to actually know if we make thrust, because we're clipping engines into each other. When you clip engines into each other, can't be 100% sure that the thrust transform is actually providing thrust. We're not going to know until we go and put it on a plane, right? But I don't want to sit here and build a freaking plane around it. Not yet, at least. Right? So what I'm going to do is build a test stand. This test stand will basically mess with our different engine designs and kind of see where it takes us. So here, what I'm going to do is what I need to do, let me say, is, so we have an axle right there. We have 3 RCS balls up front. In Kerbal, thrust transforms, so like thrust coming out of a vehicle can pinwheel stuff. You can pinwheel. I can make a turbine blade. Now, don't get me wrong. I'm not making a Kraken Tech turbine blade for our turbine. We're not doing that. I'm just using this to make sure that the thrust transform works correctly. I'll show you. So if I take this thing, right, and for instance, if we take, I don't know, let's take these. And we just turn them a little bit, right? And then move them out a little bit, like that, right? And then, you know what? I'm just gonna get rid of the fairing for a second here, and let's just test this. So, let's test to make sure that our stupid pinwheel works, right? So, where's our thrust transform? Thrust transform is there. If I take this, if we take our fan blade thingamajigger, nope. And we move the whole thing off to the side, like that. Thrust transform is pushing against this wing. That should spin like crazy. Okie dokie. This is our, basically a control to make sure that this is working correctly. Right, and we're on launch clamps, so this thing is not going into the ground. What we also could do is just move this up out of the way here a little bit. So we can actually see what the heck we're doing. Once again, the little pinwheel here is not, that's not there to, words. It's not there to for in the final engine design. I'm just making something so we can make sure that the thrust transform in our engine design is not blocked. I just wanted to make that all one assembly here, and then move it off to the side, like that. Cool. Now, take that piece, strut it just to make sure it doesn't move. Strut that. And we should be good. Okay, so let's just, I'm gonna even get rid of the fairing. Let's just make sure that this works. This is our control test. Okay, that absolutely will do it. So take this, we need to add a probe core and we need to give it some fuel. There's our fuel. We have our intake air and we need a probe core. There we go. Could put a battery on there. The launch clamps are giving me battery power, so it doesn't really matter. I'll just move those down there. All right, save. Let's put this out on the runway. Let's just make sure that this works. I forgot to put same vessel collision on. Nice drone shot and tweet. Nice. I forgot to mention your stateside. Nice, Kicks. There you go. What are we watching at NSF? They were doing some vent down tests, but I think they're done, so I think I'm gonna shut it off for now. They did a spin prime test and then they did venting tests with the new booster vent system. All right, let's do this. Go here like this, take this, go here like that, and let me just make sure the audio is equalized here. Yeah, we're good. All right, so the idea here is that I didn't tell it to be the same thing, but that we'll know. Now we know, we can verify that that thrust is actually the thrust that it's making, okay? What are you testing in Kerbal? Long story short, I'm trying to make that. The Star Raker's air-breathing engine, air-breathing propulsion system is quite literally like 2 or 3 different engines kind of. Like, they obviously took the back of a rocket, they took a turbojet, they took fans, and they took a ramjet and intakes from a ramjet and made that. They made like, it's like a combination of a Goliath and a Whiplash with the right type of intake. Now, in real life, Rockwell had no problem combining 3 or 4 engines together. I don't see why we can't do that. They had no problem doing it in real life, so. You gotta hit the English button first, Chief. Why do I see RCS gears coming? No, once again, the pinwheeling wing turbofan thing right there, that is just for testing purposes. Now, I'll be honest with you, I'm not 100% sure why hitting the thrust this way made the engine spin that way, but whatever. All right. Okay, so we know that this works. All right, so this part right here is this piece. That's this piece right here. So we got that part figured out. All right. Now, let me think. You know what? I'm going to save part count. We just need the pre-cooler. Where's that pre-cooler? So they have a pre-cooler element. Now on the real one, the pre-cooler element is the bypass blades, but yeah, there's no way we're doing that in Kerbal, so I'll have the pre-cooler be the mount. And visually, I'll make the pre-cooler look like the engine that's out in front. I think that would be a cool thing to do. There we go. Now that looks like it's one piece. All right, now we need an intake, cone intake on the front. It's actually a variable geometry cone intake, but it's not a variable geometry that, like the SR-71, it can open and close the inlets. It's a toroidal inlet right there. And now we need the ramjet component, which is the whiplash. Now, if I take the whiplash here, right? If we take the whiplash and I shut the thrust limiter off on the whiplash and the center of thrust indicator doesn't move, that means it's the same as the Goliath. The Goliath and the whiplash have their thrust transform, or where they produce actual thrust in the exact same spot. Okay? So let's test this out. Okay, so testing this theory out, what we need to do is turn on the Goliath first, throttle it up, we're getting spin. I don't know why it's spinning that way from the engine blowing on it. It should be spinning the other way, but we're definitely getting spin from that. Okay, throttle that down, shut it down. Take the whiplash, turn the whiplash on. See if we get an RPM increase on the turbine wheel. Okay. Let's try having it from a stop position. Okay. Yeah, I know it's spinning backwards, guys. I'm not 100% sure why it's spinning backwards. I'm not really interested in why it spins backwards. I'm interested in that it spins. So the thrust from the jet engine is making it spin. Now let's see what happens when we activate both of them. Our RPM should go up. Okay, cool. That works. It's spinning it. That's all I wanted to see. Yeah, that might be the reason why it was acting up on us. Really cool installing. It'd be super cool to have real moving blades. You can make turbofans, or you can make turbofans and turbo shafts in KSP. It's an idea that I was toying with before I stopped playing. Well, actually, I'd never done really anything like that. But the idea is, so I had an idea about a plane that basically had a bypass turbofan, or a bypass turbo shaft, but it was keyed on the thrust reverser. So I had a jet engine, and it had two of these things here and here, two turbine blades, and when you key the thrust reverser on this, it shoots thrust this way. It shoots it off to the sides, right? So my blades are right here and right here, and I made it so when the turbofan was in thrust reverser mode, it ended up spinning a turbine, and the turbine wheel was attached to helicopter blades. Yeah, so that way when you were in forward thrust mode, it worked like a bypass fan, but when you were in reverse thrust mode, it spun helicopter blades. Yeah. Pretty cool, huh? I wanted to put that on my gyrocopter. So you didn't need any helicopter engines. Everything was powered by one Goliath. That's what I wanted to do. Never got around to doing it. The SLS core Stage 3 intertank got its spray on foam insulation, a forward skirt visible in the background. Impressive. Very nice. Cool. That's great. That's really good. Tube. Okay, so let me just do that and make sure. Kraken bearing isn't doing exactly what I want, interestingly enough. Just want to see something. Let's try rotor, just straight rotor. I'm just testing to make sure that I can turn on the Whiplash or the Goliath. We can do either one. Do you have a way to adjust the angle of attack with blades? We could, Druid, but that's not really what I'm looking for. Once again, the pinwheel is just there to make sure that the thrust is working. I'm wondering if that thing is... It seemed like that thing may have been slowing it down a little bit. We should be pinwheeling the wings that are attached to the rotor. That's the idea. We should be pinwheeling it. Okay, the Goliath works. Shut that off. Hit the brakes. Turn on the Whiplash. Yep, they both work. Excellent. Cool. I don't know why it's spinning backwards, dudes. I'm not 100% sure why it's doing that. It's very strange. I'm not 100% sure. Theoretically, the jet blowing should make it spin this way, not the way it's doing. But, yeah, very weird. Alright, so, this works. Now... Tessa, are you here? What's the verdict on dragless fairings? Any ideas? How do we do that? Two parts, fairing inside of fairing. So, we've done this before, right? So, we need one of these, and then we need another one. Like that, right? Close the fairing there. Flip this over. Close the fairing there. Now if I take this fairing, actually, and we just do that, like that. I'm pretty sure that's how you do it. We'll find out right now. You guys want to go fast? Can it steer? No. Does it matter? No. Whatever, we can go this way. Turbine's spinning the right direction now. Yeah, it's not doing it. Hey, Mr. Teacher, I haven't been paying attention. Why are you making a spinning blade thing? I'm just messing with propulsion. Alright, we don't need the pinwheel anymore, even though that is kind of cool. We don't need it. Okay. Where I'm getting hung up here, guys, is I would like to encapsulate this in a fairing. Having this whole thing in a fairing would help with the aerodynamics. But then again, having it inside a dragless fairing would impart the drag made from the engine somewhere else in the stack. But then again, this is at the very back of the engine, so I'm actually kind of okay with this. How well does it push the pinwheel with just the whiplash? It'll do it. The fact that it's because we were standing still. That's why it ended up going in the wrong direction, I think. It's because we were standing still. You can't put the engines in a fairing. The intakes would be occluded. Well, Tessa, I might have an ace in the hole here. Give me 1 second. You know what? We'll just test that sucker right now. Well, I think the open fairing plate glitch, well, not the open fairing, the closed dragless fairing, or closed hollow, the old closed state hollow fairing thing, the same thing that we were using with our fuselage yesterday, might be our ace in the hole. I don't know. We'll find out. This thing is a 90-degree rotation and a chair away from being the lunar landing test vehicle. LLTV was pretty nuts, dude. Experiment? Yep. Yep, that's what I thought would happen. Yep. All right. Yeah. Very nice. All right. Now, okay, so for the rest of these tests, I don't think we'll need the pinwheel. Basically, I put the brakes on the pinwheel, so the thrust went, it blew by the pinwheel, and we literally went, we shot up in the air with like 400 kilonewtons of thrust. Yeah. Cool. Now, here's what we do. Take this. Let's change up the test stand a little bit. Actually, a longer wheelbase would probably be favored here because, you know, power. So, how do we mess with this even more? Does this thing have attachment nodes front and back? I need one of these. No, it has just 2 attachment nodes. Okay, cool. I'm thinking. So, there's an old glitch where you... Actually, it's not a glitch. You can get the fairing to be in a closed state, but an open hollow fairing if you attach it to a part and then gizmo that part behind the fairing base plate. So that makes it so anything inside of the fairing is still being included, but thrust transforms, intakes, whatever. It's literally the same thing we figured out with fuselages 2 days ago. Same exact thing, but being used for a different purpose. So what I need to test now is we gotta, yeah, see, it deleted the fairing. Alright. So, put this over here like this. And now, the next test, I'm gonna see if I'm gonna make it include basically the entire thing. Let's see if we can include the entire engine. Close the fairing. Move that all the way to the front, like that. Take this, put the entire engine inside of that thing. Move that up there, that doesn't matter. Go here like that, save. Alright, let's see if it still occludes. Yeah, some guy, I know about that. Let's see. Is this fast enough for you? I mean, that acceleration was pretty fast. Let me... We're gonna try it again. This time, I think we might need to add some downforce components here. You guys like race cars? You guys like Formula One? There we go. It is, Ramsey, yeah. You owe me a 10-second car. Yeah, Ducky, I wish. That'd be nice. So yeah, our whiplash is still generating thrust. Lots of thrust. And it's occluded. What about our pre-cooler? The pre-cooler is occluded. Our intake is occluded. What about the Goliath? The Goliath is not. The Goliath is making drag. See, it's making 0.5 kilonewtons of drag. All right. All right. All right. Okay. Okay. All right. So now what do we do? Now we still got to occlude the Goliath. Now I'm not sure why the Goliath is not being occluded, but where's its attachment point is down there. All right. Put this in the back like that. All right. Now take this, delete the fairing, build a new one. Is the Goliath node attached or surface attached? Some guy, it's surface attached, and it's not surface attached to the fairing. It's surface attached to the I-beam. This is my boomstick. Alright, let's see what happens. Park it for a second. Alright. That's occluded. Is the Goliath. The Goliath is not occluded again. Man, this thing goes fast. Oh, it hit the runway light. Oh, that was awesome. Damn, that thing is fast, man. That engine's got a lot of kick. Holy balls, man. Dude. Wow. Well, Tessa, I'm not there yet. I'm almost there. I got an idea. So that works. We've occluded everything but the Goliath. I do need to evaluate fairing information here, but I need the Goliath and the rest of the engine to be occluded. And I'm not 100% sure where the Goliath needs to be captured here for this to work right. I think the point is probably somewhere down there where it attaches. So let's see what this does. I know it looks a little strange, but let's see what that does. What are you trying to do here? I'm out of the loop. Atomic, we figured out that Star Raker's engines. Honestly, Rockwell was planning on taking 3 or 4 different types of engines and combining them into one. I'm serious. That basically is what it is. It's a turbo ramjet, or it's a ramjet combined with an ram air rocket engine combined with a regular turbojet combined with a bypass turbofan turbojet. It's all of that rolled into one. So, and you know, I thought it was funny when we were reading the PDF the other day and they literally just attached a bunch of names together. So like, you know, turbo ramjet intercooled. Also, I made a joke about it. It's literally what it is. They were going to take Rockwell wanted to take a CJ805-23, combine it with a Pratt & Whitney turbo ramjet rocket and turbo ramjet, and then combine that with, what was the last one? The air turbo ramjet engine. Yeah, that's basically what it is. It would have centered around the air turbo ramjet engine and a CJ805-23. The front of it would be this, and the back of it is that. And then it has a rocket engine on the back, and then it would have had bypass ramjet intakes on the sides, which is okay. So, honestly, if Rockwell's proposal was to take this and literally attach that to the back of it, why the heck aren't we doing it? Because if you look, right, see that? Right? You have your turbine fans up front, or your compressor fans up front. Get this. This is what makes this really strange and actually kind of cool. So in an air turbo ramjet engine, you start with a compressor at the front. With the CJ805, you have a jet engine And the 805-23 has a bypass fan on the back. The bypass fans are on the back, unlike in kind of a run-in-the-mill garden variety like turbofan engine. You have your turbine fan, your bypass fan up at the front. The CJ805-23 has them in the back. See them over there? When I say they were literally going to combine these together, that's exactly what they were going to do. The front of it would have been this. And when you were in turbojet mode, or turbofan mode, the bypass would have worked like a regular jet engine, right? Just that's your bypass fan. When you go into ramjet mode, you shut the turbojet off, and this thing pinwheels, right? It basically will just spin with intake air coming into it, right? Just like our pinwheel was spinning with our jet engines a second ago in our test. Those two become your compressors for the turbo ramjet. Here's the crazy part. They basically were spraying in the air turbo ramjet rocket engine thingamajigger here. This has a gearbox with a gas generator in the turbine. You don't need that. It doesn't have this. It doesn't need it. You already have your compressor blades being actuated by something. They're being actuated by oncoming intake air. So you don't need this part. So that is quite literally the front and combustion chamber of an air turbo ramjet engine shoehorned onto the back of a CJ805-23. That's exactly what it is. And then they would have intercooled it by spraying hydrogen on the blades. They were going to spray down the blades with liquid hydrogen and make an air turbo exchanger manifold using a Rankine cycle, which is okay. So, long story short, it's two engines kind of shoehorned in together. I don't understand. I don't see why we can't do that. If they were going to do that in real life, I think it's fair game to do it in KSP. What's that, Tessa? I don't understand. You linked Chinkity. So I just got buzzed by a pair of Eurofighter Typhoons that are just refueling. Oh, I was looking at ADSB. And it zoomed in on Chincoteague Island because I was watching planes around Wallops. Oh yeah, I see them out there. I see those two Eurofighters out there. Yeah, Venom. Cool. All right, so did we get occlusion on this one? We didn't. So I'm trying to take a Whiplash, a pre-cooler, and a spike intake, and the Goliath, and quite literally put them inside of one housing to make it act like one thing. That's what we're trying to do here. I'm trying to make Star Raker's propulsion systems in Kerbal. Like I said, Star Raker had no problems taking a turbo ramjet and a high bypass turbofan in real life. They wanted to just basically shoehorn them together in one housing that was basically liquid cooled by hydrogen, right? I don't see why we can't do the same thing inside of a fairing and make an engine. That's basically what I'm trying to do here. Because we were doing some fuel calculations on Star Raker earlier in the day. Oh, we need, yeah, we're gonna need a lot of kick. The thing's gonna be 1,000 tons. It's gonna be 1,000-ton plane. Easily 1,000-ton plane. So right now what I'm trying to do, I have my engine configuration. I'm trying to see if we can occlude the dang thing inside of a fairing. Honestly, I think I'm just gonna make this thing gigantic right now. Put this like all the way at the end, and then take this fairing. We're just gonna go crazy with it for a second. The reason why I'm putting it inside of a fairing is because the Goliath makes a lot of drag at high speed. As it should. It's not really designed for that. Alright, so the whole thing is inside of that fairing. Let's see where it gets us. 4-engine tankers out there too. Cool. Yeah, Ducky, the hydrogen. Like, you know what the messed up part is? I thought the propulsion would... I've been saying the past couple of days that the propulsion is going to be the hard problem. That's going to be really difficult to figure that out. It's actually not bad. I don't think this thing is as hard as I was making it out to make. Don't get me wrong. There's going to be 10 of them, and they need to be fed by liquid hydrogen from wet wings. Yes, that is difficult. But I don't understand why we didn't do this. Like, this is a really good idea. Like, it's actually pretty damn smart. Alright, so the Goliath is occluded. The Whiplash is occluded. You can tell because everything literally is 0. And it's not moving around. If you look at the aerodynamic analysis on this, it has the ACD. Now let's take a look. Interesting. The pre-cooler's being marked as occluded. Okay. Interesting. The Goliath was the intake path before. Yeah, okay. All right. Alright, now what I want to do is test to see if we can just get the intakes open. I just want to see. Can I... I'm wondering where the intake air transform is for this thing. Interestingly enough, I'm not sure. And it kind of showed that we don't want to include the Goliath, but that doesn't mean we can't get a little bit more performance out of this thing. So we're testing best ways to occlude engine intakes, but also keeping the intake air open. Yeah, I'm trying to... So, 95, I just got through explaining it a second ago. Long story short, Star Raker's air-breathing engines aren't just hydrogen SR-71 motors. They are quite literally an off-the-shelf turbofan with a NASA-designed ramjet attached to the back. Yeah, that it quite literally is... 2 engines just kind of put together. So I've been saying, well, if Rockwell had no problem doing it, if that's a thing that you could do in real life, just combine it together, why don't we just do it here? Right? So I'm working on dragless fairing engine designs. Basically something that's going to give us the kick to move a 1,000-ton plane around. Looks like they'll be headed back to Losamouth. I have a funny feeling they just ran an intercept run on a bear or something. Yeah, maybe. It's... Yeah, talk to Star Raker. We were doing the fuel calculations. This thing's gonna be nuts to take off. Yeah, it's gonna be pretty crazy. So, I'm testing propulsion systems for that part. So... That's occluded. Our pre-cooler is occluded. What about our front intake? The front intake is not occluded. Interesting. Yeah, you want to see? You want to see our design? Yeah. It goes fast. Very fast. The pre-cooler is occluded so it can't have any airflow. Does the pre-cooler work when it's in line? If it's in line and attached to an intake, it still should work. Should it not? Right click when it's moving to see if it has airflow. Ah, we're just gonna have to test again. Why are we making this stuff occluded? The Goliaths make a lot of drag when you're going fast, though, Force. If I can find, well, yeah. If we can find a way to occlude it while it still has intake air, then might be in business here. But if not, yeah, we're just gonna have to send it. We got a way for the engines to basically be inside of a fairing. Like, the whiplash is still occluded, yet if I only activate it, we're still getting thrust. We have an engine that's occluded inside of an open fairing that's has set close state with the engine plate, right? We're getting thrust from an engine inside of the fairing. If we're able to get thrust from an engine inside of the fairing and have it occluded, I don't see why we can't do that same thing with intake air. We just got to figure out the right place to place the fairing. Is the Goliath able to work alone? Yep. Certain parts need to be inside of the fairing flanken for it to be occluded, but yeah, with what I'm trying to do here, you should be able to do it. If you put a small nose cone on the shroud node on the engine plate, it will make the fairing occluded too. It's kind of what I'm getting at. The pre-cooler did not have air intake flow. I got to figure out where the transform port is. If that makes any sense. But I did get the shock cone intake to be occluded there. I'm wondering if we can just I gotta test some stuff by moving stuff around here. He said but. The pre-cooler's occluded and we'll have airflow. We gotta figure out where the intake transform is. There's a node somewhere on there, 95, somewhere on that part. There's a node that says this is where the intake air goes in. If I can find the node, just like there's a thrust transform, if we can find where it is, we could. There's theoretically a spot where you could occlude the pre-cooler and have it still flow. If I can figure that one out, it's gonna be a big deal. I've never seen someone separate an air intake transform from the actual part. You can do it with thrust transforms, no problem. I don't see why you can't do it with intake air. Have you seen 2001: A Space Odyssey or read the book? Is Star Raker basically one of those planes that were taking people to the moon operated by Pan Am? Star Raker came 10 years after 2001, dude. The Goliath is not included, no. No. You're getting intaker from the Goliath. Yeah, I know. What fairing does occlude the Goliath? I think the Goliath's occlusion point is on its attachment point because it's specifically designed to be radial attached. However, I think if we attach a Goliath on the forward node right there, it might block the intake, which is not going to be ideal, but I think that's its occlusion point. I'm trying to figure out where it is with the intake and the pre-cooler. This test will basically be for the pre-cooler. Let's see what happens. It blocks the Goliath if you attach to the forward node. We don't want to do that, which means, Tessa, that means it's attachment node. The attachment node is the occlusion point. And that, once again, this is something that we got to prove, but I don't really see how, if the thrust transform we can occlude something like that Whiplash engine, it's definitely occluded. You can always tell someone's occluded from the aero debug. If the ACD says 0, the game isn't simulating the airflow there, right? Whereas if you look at this part, the area coefficient of drag is 0.64. That's occluded. The engine is occluded, but it's still providing thrust. I don't really see how, if we can separate a thrust transform from its occlusion, why we wouldn't be able to do it with intake here. So, it says the pre-cooler is occluded. Let's throttle up our engines and see what happens. Nope, still occluded. What about this? Blueberry, 15-month resub. I don't mean to bring you out of a train of thought, but taco update. Vert. Oh, nice. Wait, what the hell? Wait a minute, what the frick? Dude! No. How did you do that? I mean, you guys know that that's a Toyota engine, right? With a Ford supercharger on it. Ooh, nice nose. Yeah, somebody linked me one of these pictures before, dude. Yeah, that A3, the A3 intertank's looking pretty good, dude. It's just a test fit for now. That's an SVT Cobra supercharger on a Toyota V8 inside of in a Toyota Tacoma. I don't hate this. I really don't hate this, Blue. That's actually really cool. I was gonna say, it's not bolted up, but you're gonna need to make one crazy adapter plate. I would be kind of... I mean, dude, you probably already know this, but I'd be kind of careful. Don't you think the supercharger will blow out that plastic intake manifold? It's a one-off kit. Late manufacturing out of Australia and New Zealand. It's metal, it'll hold? Okay. I was gonna say, that looks like plastic. But if it's metal, then never mind. Yeah, interesting. There's kits for the supercharger. That's cool. The second rate, that thing, yeah, the engine, I'm not, let me put it to you this way. I'm not worried about the engine. That Toyota motor is, it's not a 1UZ. I forget what it is. But it's, yeah, that's cool, dude. That's really cool. It's a 1UR. Yeah, okay, so it's... From what I'm seeing, EJ, from the EJ test, it's to have intake air with also including intakes. Yeah. Oh, don't worry about it. It's all good. I suppose a better candidate to test here would be the Goliath. Okay. A better candidate to test here would be the Goliath. Let me look at something. All right, so I'm gonna move the Goliath up here, like this. That right there should occlude the Goliath's shape, but I'm wondering if the intake is open, what happens? Our intake's wide here, so let's see what this does. The last picture in the album has the umbilical. Yeah, Poison. Dude, the real one has the real one basically has a intercooler in it. The real one. I say the real one. This is an intercooler. The blades that act as your bypass for your jet engine, so when you're in Goliath mode, so to speak, at higher speed with the ramjet, they act as intercooler. It's an intercooler. It cools the intake air going into the ramjet. Because, you know. Nominal. Any of this occluded? Nope. No, Kuro, I've not heard anything like that. Closing the intakes does change stuff, Oculus, yeah. Alright. Alright, let's see what this does. I've been following it back, but I don't really want to talk about it until we get some like concrete peer review, but it looks good, yeah. I'll do some testing on IM to see if I can make the pre-cooler occluded, but still have intake air. I mean, 95, to be honest, it really matters more with the Goliath. The Goliath, because I would like it to be occluded at higher speeds when the whiplash is doing its thing, right? We did some, like I said, we did some kind of basic analysis on, you know, how much power we're going to need. And the Goliaths, you're going to need a turbofan. You're going to need a Goliath to get this thing off the ground. It's not occluded. It's been replicated by Varda Space Industries. Is it bad that I want LQ99 to be only possible in 0G? No. That's not a bad thing. Didn't do it. The Goliath doesn't really need its intake if you have pre-coolers and a shock cone, so you can completely enclose the Goliath just fine. You think so, Tessa? You think we should just cut the Goliath's intake completely out? Put a fairing on a piston to push up and pull the Goliath in and out of the fairing. Chillin', that's a good idea, but you'd have to time warp to get it to work correctly. So when you put the vehicle out, it'll register the Goliath as occluded. Even if you move it out, right, you'd have to, like, stop the game, reload it, like load a quick save, which we know is a no-no, or time warp, not fizz warp. Time warp where it freezes the vehicle for a second. And then on physics reload, it'll read that thing's out of the fairing. It doesn't, it doesn't work that way. We could do it with a payload bay to toggle occlusion if we really. Hey, Minsus. I'd prefer to go with the fairing solution. Payload bays would work, but we'd need to start messing with payload bays, and keeping track of what's occluded and what isn't is a big pain in the butt. I'd prefer to just do it a more passive solution, because this is going to be a complicated vehicle to begin with, guys. It's going to be hard to fly it. I agree, Tessa. Okay, so okay. So we're at occlude the Goliath and the Whiplash, and then don't occlude the pre-coolers. Okay, I can do that. I have one more idea, if you don't mind. And if you do, I don't care. It's my stream. I'm doing it my way. Give me an interstage node. Shut the interstage nodes off there. Get rid of this. We can get rid of those. We don't need that. Take this, attach the fairing to that, get rid of that, get rid of the truss structure. Now, that's a closed fairing state because we closed it on the engine plate, right? If I take this and we make an open We have the fairing set to an open state. What is it going to do? I figured out how to occlude the pre-cooler, but I still have intake air. Wait, no, I'm wrong. Ignore me. Okay. See, I'm wondering about occluding them when the fairing's in a terminated open state. There's different states for fairings. You can either terminate them and have them basically look like a cup, right? That's technically a fairing open state, or you could close them on something, which is an open state closed fairing, right? Open state closed fairings are good for doing what we're doing with the whiplash, and it's good for the fuselage aerodynamics. But if we have terminated fairing open state, I'm wondering if that makes the thing work. No. And the Goliath is not occluded either. Is the whiplash occluded? It is. Okay. Sorry for the random question. Is KSP2 too buggy? Seeing no one in it just hit me. That is realist times since you play KSP for a while. Dello, I'm waiting for some of the bugs to get fixed. Right now it's kind of bare bones. There's not much that you can do in it. Give it some time. $95. The more I look at this, the more I think that the intake air is at origin point, which, see how the intake's right there, but it might be based off of attachment. So if I take this and see how the transformer's right at the front there, that might occlude it, but still have intake air. And for whatever reason, the Goliath is still not occluded. So I'm gonna move this whole thing up and see what that does. Honestly, I think the intake transform is in the same spot as the normal part occlusion point. The part occlusion point is what's called an origin point of a 3D object. Do we know when the next KSP2 update will be? It's gonna be soon. So it's like KSP the first year or worse. It reminds me a lot of Kerbal 1 from 10 years ago, Dallo. And people have a short memory. If you remember how Kerbal 1 was back in the day, it was pretty bare bones. No moon, no nothing. Like, there was no moon. You just went up and then came right back down. That's how Kerbal was back in the day. They're co-planar, I'm pretty sure. Thanks, Offlead. I don't know if this will help you, but I used an engine plate instead of a fairing, and the pre-cooler was included along with its airflow. Yeah, I see it. I see it. Okay, cool. It seems like Intake Air is working off of a different Unity plugin than how thrust transforms work, so that's okay, that's fine. It's not that big of a deal. Just get rid of that. And so now if we okay. What I'm trying to do here is what was I doing? Sorry, I lost my train of thought for a second, dudes. Yeah, okay, yeah, I got you. That's gonna be hard to make this work then. What I wanted to do is see if we could cup an open fairing here, right? Cup the open fairing and have the intercooler inside to make it look like the bypasses, but I'm not sure that that's gonna work how we want, dudes. Yeah, we have to make sure the thrust limiters are coplanar. That's right. I'm seeing if node attaching the front of the Goliath is going to occlude it. Like, all of it. So, let's do that. Keep the pre-cooler out in front. See what happens here. Come on, baby. It's a combination of the Whiplash engine and the Goliath engine. A lot of it's going to be visible inside of the larger intake housing, so it won't be terribly... Yeah. that's the end of that. Okay. It's possible to have the engine, fuel tank, structural parts be occluded, either using fairings or engine parts, and have it work. However, you cannot have intakes of any kind be occluded. Yeah, that seems to be the case here. It's alright. Okay, so now the next thing that I need to test is, can we change the fairing? That's where this needs to be. Because now that this is node attached, can we change the fairing shape? Alright, let's see. Let's see if this works. That's basically what I'm doing right now, 95. Yeah, I'm trying to include my thrust components, not intake components. Yeah, if it's behind ramp intakes, I don't really care. It's not a big deal. The Goliath is not occluded in this one, in this design, in this way. It's not occluded. Damn. Oh, it is. Yes, it. Interesting that the intake is occluded, but the origin point isn't. It's weird that we can do the reverse of that, but that's because it's node attached, if I had to guess. If only we could get it to reverse. If we could get the intake to open, but we have part occlusion, then we'd be freaking golden. And let me check something. Remember how you changed the SRB gimbal to 10 degrees? Any chance of playing God in the config? I don't think we... No, that not in this particular regard. No. Excuse me. So it seems like the occlusion point for the Goliath is still over here somewhere. It's still on its radial attachment piece, which is interesting. So if that's the case, here's what I want to do. I would really like it to be able to. I really like to be able to see the turbofans moving in there. So let's do something like this. Where does the Goliath radially attach? Back there. So basically right on the edge of the whiplashes. So excuse me. So let's go in here like this, edit the fairing. Sorry. Let's see if we can just capture the occlusion point here with this thing. I think the capture point for it to be occluded is up there somewhere. And if that's the case, then yeah, this is going to be pretty sweet looking. Because you'll still see the fans move. Let's see what happens. Yeah, it can be fed from other intakes. That's correct. We're gonna feed it. See, if I can occlude the Goliath shape inside of a fairing, we can make our engines literally more aerodynamic, right? And we can make the intakes run off something else. No problem. Easy peasy. Come on, occlude it. No. Hey Dre, what's going on, man? Yeah, I guess we didn't need that. Alright. Yeah, that didn't work. Alright, fellas, I think I've seen enough. If we mess with this more, we can mess with it more. We can absolutely do it. But we can mess with it more, but I honestly think that this might be fine just the way it is. This is, what, 4 parts? And this does have the Goliath's intake wide open, which might... I mean, I don't know. I think the thrust that we're going to make, and if we overclock it on top of that, I think we'll be fine. To be honest with you, I think we'll be perfectly okay. That's correct. Aqualux, yeah. What I wanted to do from here is develop some type of FADEX system with like a cow controller that will mess with the thrust limiters. Why thrust limiters and not just toggling the engines on and off? That way we can have all the engines basically on a single activation, and we can slowly ramp into the right mode with the ramjets. I thought that would be kind of nice. Like, I'll have a cow controller, and we'll bind the cow controller to throttle. Actually, no, that's not a good idea. We'd need to bind it to a secondary detent. So, like, at one end of the cow controller, the Goliath's doing all the work, right? So it has higher thrust. And then we could move it slowly forward, and at the other end of the cow controller, that thing's doing all the work, and this thing slowly ramps down. The Goliath will thin out as you build speed up beyond its cruise, and the Whiplash will ramp up. Yeah. Yeah, alright. I think this is... Yeah, it'll work. Now, Tessa, the last problem to solve here is that we need a 1.8 meter diameter output. That's it. That's the last one. Now the Goliath does have an open attachment node. Well, that's what I mean. We don't want to overheat the turbofans, Tessa. So the cow controller just shutting the thrust limiter off, right? On the Goliaths would keep them in the on state, but it makes it so they won't overheat. The last thing we needed is a 1.8 meter diameter output. So I was thinking we could do that with the fairing in the front piece, like this. That will still shield our intake a little bit. We can put the fairing where the stators are, right there. And that doesn't look too bad. And then take the ruler And, you know, this will still give us some whiplash occlusion, which is pretty cool. I just got to see if we can set this to an open state here with the fairing. And still have the whiplash be occluded, but not the thrust. It's close. Hey, Glonias, thanks for keeping it chill this afternoon. Have some pocket change. Thanks, buddy. There we go. This needs to be set to absolute here, or else it's not going to be on the same axis. Okay. If the whiplashes are connected straight to an engine plate and the engine plate has even the teeniest shroud, they will be occluded wherever you gizmo them. Oh, that's cool. Doesn't really help with what I'm trying to do, but... that's still cool. You wouldn't have to worry about where the fairing is. But I want the fairing for the 1/8 diameter anyway, so... Cool.
Should we wait until tonight?
It's your favorite song, John. There we go. That's it. That's the engine. It's kind of a little bit different than this one, but I could put a convergent divergent nozzle in it though. We could do that. But that does look really sharp. I like it.
Baby, why should we wait until tonight?
Do it.
If we make love in the light of day, feels alright.
Okay. Well, in Glonius, the fairing. The fairing would be the master attach. The backside of the fairing is open, so yeah, it would just, you could just put anything with an attachment node, you just attach it, gizmo into place. You wouldn't see that from the outside. Yeah. That's true, I2 Rocket guy. Alright, let's make sure this works. Now, the thrust transforms are dead center, longitudinal. It wouldn't mess with it. I could make it. Yeah, I'd just have to go. I'd have to go sculpt it out. No problem. Oregano. Maximum drench. So the intakes and turbojet mounted like that in the Goliath does not affect the Goliath's operation. Nope. No, it turns out that, yeah, Jaka in-game, yeah, and it turns out that's what they were going to do. Turbojet's supposed to be in the front. Seriously. Look. Turbojet's in the front. Bypass fan is behind the main turbojet. Turns out they made jet engines like that. The CJ805-23, which is what they were going to use. Yeah. It's pretty freaking cool, actually. Yeah, it's backwards, which is pretty nuts. All right, how fast do you think this is gonna go? Actually, hang on a minute. Well, Aqualex, what I wanted to do is put an open fairing on the front and basically do this to the front to make it look like it, right? But this will work, dude. And this thing is 1, 2, 3, 4, 5. It's 5 parts. So 50 parts for our engines. I'm good with that. That's fine. Look at this thing. Look at it go. Whoa, okay. Stabilize. We're gonna die when we hit this hill. Either that or we're going flying. We're going flying! We're going flying! Ah! We're dead. We are so dead. Dude, that was awesome. That was awesome. Alternate engine plate design where the engine plate is the attachment point and the engines are included. The engine plate still has 7 free nodes. Oh, that's not bad. Okay. Can you guys just excuse me for a second? Just one quick second. I just need to check something to go over some documents. What the hell's VSR 3 mean? What in the jeb are you working on? Star Raker's propulsion systems? That gets us what we want. Now I want... Oh, you butthole. Now I want to make the rocket a convergent design thing. Oh, man. They're both working, Jaka. Here, we'll test it again, dude. I'll show you. Dude. Oh, I love it. I love it. So there's regenerative cooling out here on the entire thing. There's regenerative cooling. So take a look. This is basically the inlet for the bypass for the ramjet. So it's the bypass ramjet inlet. I swear I'm not just putting words together. And I wanted to use a fairing, but flags are physics-less parts, especially when they're just in straight flag mode. So that's right. What's included in your design? Just the whiplash in this one. It's just the whip. All right, hold on. Move this out of the way for a second. It could be better. It always could be better. Hold on one second. Yeah, I like that. I like that. Yeah, yeah. Yeah, yeah, that's good. Yeah. That's real good. Yeah, that's good. Yeah. Yeah, that's freaking sweet, dude. It doesn't look exactly like it, but so our ramjet combustion chambers are a little smaller than that one. Whatever. If you're going to do that, you need the volume for the afterburner's combustion area. Okay, one more time. One more try. This is making me feel things. Let me work on the throat. Let me work on the throat. Let's get the throat. Let's get the throat and the nozzle right. Hold on. Hands. Shh. 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 Could these fit on the K90? Nah, I'll just make a plane. I don't know what you're talking about, Oculus. I don't know what you mean. The nozzle's too small. This VDJ is the throat goat. Using another fang to close it on a custom diameter. It needs to be a 1.8 meter nozzle for it to look right. It's got to be a 1.8 meter nozzle. Believe, just roll with it. Trust me on this one. If you want to really OP this, clip the nerve engine into the whiplash. Nah, I think I'm good with this one. Yeah. Taste the chrome! Do I have like a metal finish? A brushed metal line? We have gray. We have another shade of gray. We don't have 50 of them though. Shut up. It's not funny. This thing's cool, man. I think it's really cool. Oh, that's so cool. Wait a minute. What if we did that? And then I changed this to the dark gray that we have. That does not look nearly as cool. We're going for cool factor here, okay? That's fine. This looks good. Yeah, baby. Close enough. Excuse me. No, I believe I haven't. Shouldn't these bolt into place on the seaplane? No, Mile. No, I don't think they will. We had to, Crex. We had to, dude. Yeah. I had to combine a Goliath and a Whiplash into one motor with a pre-cooled intake. Because quite literally that's what Rockwell was going to do. Seriously. They attached a turbofan onto the front of a Ram Air rocket engine. They just literally claps the two engines together and put a rocket nozzle around it. I'm dead serious. We've been reading this. That's what they were going to do. And then they were going to pre-chill intake air by spraying liquid hydrogen on the compressor turbines. At least I think that's what this is doing. I'm not 100% sure. It's not an SR-71 engine cannon. It's kind of like an SR-71 engine, but the ramjet is not a straight ramjet. It's not a straight bypass like the SR-71. This is intercooled. It's an intercooled bypass, or air turbo exchange manifold. They have an intercooler that spins. The turbine blades are basically an intercooler. They spray them down and they get cold and they compress the air into the ramjet, which is This is like a step above SR-71. But similar idea. Yeah, this thing was going to be kind of nuts, actually. And there's supposed to be 10 of them, by the way. Not just 2 like on the SR-71. There's supposed to be 10. Because, you know. Can you explain what happens in this motor for dummies? From front to back. It's... okay. Yeah. See this? Okay, you see that engine right there? It's me. That's a CJ805. The CJ805 is an F4 Phantom engine. It's a J79, but the CJ805 was the civilian version of it. The CJ805 was converted later, right? The difference between a J79, so it's an F4 Phantom motor. The difference between the 805 and the J79 is an afterburner, okay? So this was not, this was just a straight turbojet, okay? That big thing in the front is the oil pump, by the way. Later, the CJ805-23 had an attachment that they put on the back. Instead of an afterburner back here, they put a fan. So the turbine was blowing air into the turbojet was blowing air into the turbine, essentially making one of the first high bypass turbofans. Right? High bypass turbofan. But in kind of general turbofan design, you have a jet engine that's blowing on turbines, right? And there's an axle that connects to the big fan, the main bypass fan on the front. This is flipped. This thing is over here. Okay? Remember that. Remember that. And it spins freely, independently of the turbojet. So this fan is over here, and there's no axle that goes through to the front. It's a jet engine blowing on a turbine wheel that spins the fan. Okay? The turbines and the fan are in the back. Okay? That's the big thing to understand. Okay? Now, look at this. That's this part right here. See that? So you have your CJ805-23, but the bypass fans that are in the back are a little bit different on this one. Okay? The bypass fans that would work in your high bypass turbofan design aren't the ones that would be on a CJ205. It's not that. It's kind of like it. It's that. Yeah, that. What you're looking at here is an air turbo ramjet engine. Okay? An air turbo ramjet engine has a turbine and a gas generator. Gas generator spinning a turbine through a gearbox that spins compressor blades on the front. If you take the air turbo ramjet engine, this is a concept that was thought up by NASA. You take this design right here, get rid of the turbine, get rid of it completely, and take your 2 big compressor blades in this design and make them the exact same thing that's on the back here, you've essentially made a high bypass turbofan, turbo-cooled ramjet. Understand? So down at low altitude, it works like this. At higher altitudes where you need to go fast and basically make up for the fact that you have no first stage, it does that. This, minus this turbine and gas generator design here, because you don't need it, is attached to the back of a CJ805. That's what this is. It is quite literally, if you take a Goliath and a Whiplash and Kerbal and you combine them into one unit. And then, those turbine blades are a little bit different. They're intercooled. It's an air turbo exchange manifold. This whole thing's running off liquid hydrogen. You know, the turbojet, the CJ805 runs off hydrogen. They can make it run off hydrogen. That works, right? A little weird, but it works. These blades that are the bypass at low altitude become your compressors for your ramjet at higher altitudes. But you have the same problem that the SR-71 had. the intake air that's coming in here at supersonic speed at post compression here gets A, it's going really, really fast, and B, it's really, really freaking hot. So they came up with the idea. From what I can tell from this, it looks like they're spraying the turbine blades with liquid hydrogen to cool them off. And that's using a Rankine cycle or something to exchange the heat with the intake air and pre-cooler, your intake air for the ramjet. And then, after you they basically preheat their intake air, right? They shoot liquid hydrogen in with the ramjet fuel injector assembly and basically make a rocket engine. Yeah, it's a rocket engine. Kind of like an RL-10, but on steroids. Yep. There is locks. Yeah, there is locks. They could inject locks into this too. They were going to do that as well. The important part for the higher speeds is that at higher speeds, the intake decelerating the air does most of your compression. Yeah, they also decelerate the air with a variable geometry ramp intake on the inlets here. That works kind of like it works like an SR-71. And then they close the intakes to the turbojet. So at low altitude, Goliath. At higher altitude, Whiplash. Does that make sense? That's what I'm trying to replicate it to me by making this. That's what this is. It's that. You have a turbo ramjet in the back, right? See the turbo ramjet? And then you have a high bypass turbofan up at the front. Now, in real life, the bypass turbine fans were going to be your pre-cooler. I can't do something like that, so the best I can do is make the pre-cooler look like the engine up front with its conic intake. So this is basically supposed to look and function essentially the same as this. And I've been saying this all stream, once we figured this out. If Rockwell thinks it's cool to, they thought it was cool to basically just take an air turbo ramjet concept engine and shoehorn it onto the back of a turbojet. If they were going to do that in real life, I think doing it in Kerbal is completely fair game. So, there you go. No problem, dude. Now we need to fly with it. We could attach it to something. How's your fancy spaceship? It's doing fine, Benton. This is the engines for it. We're gonna have 10 of these things on this. Here. Let's think about how we want to do this. I just want this thing to fly. We just want to fly it. So I'm gonna make something a little stupid looking here. Tested on my 747's extra pylon. Will 10 of these fit? Yeah, Ducky, they will. You know what? I changed my mind with that part. I don't want that up there. Just, we need a nose cone on the front of the fairing, so just let me get a probe core. And the nose cone. And then grab the fairing. Yeah, okay. I might need a different wing design here.